All right, so this is the first of a new set of videos that I'm going to be doing. Just sort of a video blog of the development I'm doing, and I figured I'd invite you guys all along for the ride. Uh, Unlike other videos that are like to the point and stuff like that, I mean, obviously, if you look through all my videos, I've got like videos that are 8 hours long, and then I got videos that are 10 minutes long, 5 minutes long. So if you're watching this, just know this video is designed to just capture what I'm doing for coding. It's kind of a video log of what I'm doing, kind of collaboratively, so people want to come in and just kind of work out with me. The primary goal of the videos right now is for me to just produce Go code and to kind of rubber duck it. As of this moment, I've decided I'm going to try to keep my face on the screen so you can see me get frustrated and everything as I go through it. And sweat and everything. Just got off of a run. I'm kind of sweaty and hot, but so that's what this is about. It's also the first stream I've done in the game and software development category, which I've made fun of a lot. But this is definitely in the game and software development category, so I'm going to keep it there. When we're doing science and tech related things, Kubernetes and stuff, they'll be in a different category. I don't know what else to say. I'm just going to jump right into it. This specific series is all going to be in its own thing. So everything that's related to doing Go programming on this particular project, which is a really small, tiny little project. It's also a lab project. So a lab project means that it can be used in many ways. So I'll be making a lab that goes with this. People ask me all the time, what should I do to get coding in Go? And I think the best thing to do is just jump in with a project that you either, taken another idea from somebody else and just reworked it your own way, as TJ Hollowaychuk, who made Express, recommends, or, just do your own thing. So in my case, I have a very specific thing I need to build that I've already built in Bash, so I know what the requirements are and stuff. But we're going to be going through the project from beginning to end, and I'm going to try my hardest to keep kind of organized about it. We're going to be doing Pomodoro sessions. So when you see the little tomato down in the bottom left, that means that we have 25 minutes left. I am going to keep to 25 minutes traditional Pomodoro session timers. These are not normally the time blocks that people use for software development. They usually go up to 45 minutes or even 2 hours. It just depends. We're not going to get into any of those things. And I'm going to make one request before we get going here. And I don't know how to put this out there. I'm just going to need the community to help me police this. As I continue to do these, I'm going to try to do more of these every day, every week even. And by the way, if you are not here for this, you want to come ask questions or something, take a look at my schedule. So go to rwxrob.tv, and then it'll give you the Twitch site, and then you add /schedule to the end, and that'll show you my schedule, which is right here, and it'll tell you what I'm doing and stuff. Okay. Wait, why is it saying there's no... Oh, I've been playing music this whole time. Damn it. All right, well, not anymore. There we go. We'll take it out. It's some nice introductory music, I guess. Hopefully YouTube won't die on me on that. I'm going to go ahead and stop that, though. But there won't be music ever. Maybe they'll do a little bit of intro music. It's kind of fun. And, outro music and stuff like that. But in general, I'm not going to be doing music. Because music obviously causes problems. So there we go. This is the beginning of this. So if you want to know what else is going on, you can come over here. You can see beginner boosts here, and please tell me that's not, it doesn't say muted right now. Yeah, I need to change this, so give me a second here. So if you ever see when you see the icon right here, let me refresh this. A little bit of logistics here on this first one, because I haven't done these a lot. At least I haven't done them this way. When there's a little thing there, that means it's been recorded, and it's going to be on YouTube. I don't save any VODs on Twitch, It's just too much of a hassle to save videos in two places. So I save all my videos on YouTube. You can go out to YouTube and see the saved videos. I'll make a playlist specifically for this project, Go Programming, conf-go. And I'm going to try to keep all the projects in their own playlist, and I'm going to organize the playlist, of course, multiple playlists, stuff like that. So you can come back if you want to just kind of follow along while you're doing your own code. If you just want to mute me and just want to watch somebody coding in the background while you're doing your own coding, that's fine too. And one of the reasons I have a lot of people who don't like it when I talk, and I guess everybody's different. They all got different tastes. Some people don't like it when I come on and I start coding. They just want me to code in the background and watch. But I figure, I might as well put my face on up here. I am going to be wearing my hat, not because I'm ashamed of being bald. I have no problem with you seeing that, but mostly because when I wear a hat, it keeps the lights down out of my eyes. And coding, as you know, is very intensive on your eyes and stuff. So, all right. So let's go ahead and get started. And we're going to start outlining the project and what we're going to do and everything. So is Go what you recommend after learning Bash? Absolutely. My recommended languages, in case you're wondering, this is all in the boost, by the way, but my recommended languages are unintuitively Bash as the first language because you're already doing it. If you want to count that a language, technically it's a language. That's why I count it. And then Go. I really think Go should be the next one. That is not a popular opinion. There's a lot of people who differ with that. But those are the two preferred hacker languages. After that would be Python. These days, Go is way hotter than Python in the security space. You should see all the hacks and stuff that are coming out in Go. Hackers have overwhelmingly dismissed Python and said, we are taking Go because they can embed old exploits that they were written in C and they can put them in Go and they can go to town. And you guys, I'm going to ask you for some help here too, because every time I stick a mic in front of me, for better or worse, I don't code. I talk, and so I don't code. I don't know if you've noticed this, but when I don't have a mic or a camera on, I get a lot of coding done. When I have this stuff on, I don't get shit done. I don't focus. I end up explaining things and talking, and even because I like it. And I'm not blaming. There's no blame going around here. This is just the nature of how I am. So if I'm going to do this and accomplish anything at all, there's going to be large amounts of time where I'm not going to be responsible. I'm just going to be coding and I'm just going to be talking to the mic as if I were playing a Dota game and there were nobody there. I'm just complaining about what's going on. Okay. So that's what's going to be happening. So let's go for this. So a couple things here. We already have a project built for this. So if you want to follow along in the project, it's called cmd-config. No, it's not. No, it's not. We need to actually make that. That's going to be interesting because we're going to need to. I'm trying to decide whether we should put the command tab module in there as well. I don't know. So command tab is a way of encapsulating a command to go with your library. This is just the library that we're making right now. I think we'll just keep it as a separate library. So conf-go. I've already cleaned it out. It's already got a branch, a Git branch, because I have. I think I already committed that. What is up? Why isn't it showing them all? I need to open this really quick and go check if I have the branches up here. So this is the code, and this is the old code that we're redoing. So this is the old one. It works fine. Henrik had a commit. Og had a commit. The problem with this is it's based on JSON, and I am dropping the JSON dependency for reasons that I'll talk about as we go. I'm not going to spend a lot of time justifying my decision. I'm just going to tell you why briefly, and then just why I'm doing it. So this is a module that's already exists that I use to generically store configuration information according to the Free Desktop Foundation standards. The X, you've probably seen it. There's standard places in Linux to store stuff, so we're going to store that there. But it also is just a generic way to read that information. So this is clearly this is main, but see I made a branch here, JSON this is going to be staying. I'm going to be committing to main. I happen to follow the process of committing to main as my development path, and then having then marking branches and releases, so that if you download main, you're getting the latest and greatest. There's a huge debate about how you should do that, but that's my preferred method. And so we have conf-go. Again, this is used by other tools, and I'll get into what it's about, and we're gonna write all of that. We're actually gonna write a spec together as a part of this process. So one of the goals, if you're coming here and you're brand new, you've never coded Go before, I'm gonna assume that you don't know any Go, what we're talking about, and I'll talk about what you have to create and how, come, and why. But we're not just gonna talk about Go. We're gonna talk about how to organize a software project and how to get started on a small software project, and how to follow Git ops. How to follow the Git process during your own process of development, even if you don't have other people around, just to get in the habit of doing it, and to keep track of things and not get lost and stuff, because it's already there for you. So we're going to be doing all of those things. We're not just going to be learning about conf-go. We're going to be learning about the process of development, Git-driven development, specifically GitHub-driven development, in a collaboration, and that includes this branching and stuff. And this JSON branch triggered that. So just to preface that, what I've done here is I've already branched, because I have a lot of people that are dependent on this other code, right? And that if they've done Go right, they've got their checksums and they are locked to that tag, and they are going to be fine. But when they go to do an upgrade or an update, they're going to find that I don't support JSON anymore. But I don't want conf-go to be I don't want it to be locked down to the JSON format that it was locked to before. I want to reuse this. I'm not gonna create a new name just for the one that I turned out to want anyway. So it's not really breaking dependencies because the version 1 is out there, right? So that's how software is. And oh god, here's other people that use it. A few people, mostly me. So yeah, so we're gonna go back to main here, and I'll talk about why I'm making the changes and everything as we go. So, but there's some other projects that use it, and we'll talk about that. This has all been ripped out. I've already ripped all of this stuff out. So we're starting. So assume we're starting with like a fresh thing here. The 101 stuff. No, I haven't. Ask me about this tomorrow. Tomorrow's AMA time. Okay, 5-shot. Can you bring it up tomorrow again? Just got started coding. Yeah, so tomorrow you can come on in and have a peek. So yeah. I mean, if you guys have any questions about what I'm doing and why I'm doing it, those are relevant. Okay, if they're, how do I code and go? That's maybe not the right question for right now. I do actually want to get stuff done. So this is essentially a new project. Now, there's something about Go I want to teach you about right now, really quick. About GitHub, I mean, GitHub has a thing where you can make, you can go to GitHub and you can make a template. I don't want to get caught into this, but we still have stuff on this first introductory Pomo, so we're fine. You can go out to GitHub and you can actually make a new repo. And you can make the repo and you can say, repository template, start yours from a template, right? And you can say, I want a new repo that is from the bash command template, for example, right? And I'm just going to say sample cmd. And if I'm using the graphic, I don't use the graphic interface. I use the command line for all of this, but you can do it that way. And then you do create repo, and then you get, it actually copies this, puts a little note up here that what it was built off of, and it makes a new one, and it gives you all the fresh boilerplate, it's called, code to fill out and to fix and change and stuff like that. So step 1, get yourself a GitHub account, obviously. And step 2, start considering those template repos that have the stuff in them that you want to repeat over and over again. We actually, somebody, a member of our community, I can't remember who, actually hacked my newx command, which is in my .dot files, to download and use a template as the basis for a new command when you want to just make a one-off new command really quickly. So this approach of using boilerplate and templates is really well established in the software industry. And, it saves you the hassle of having to redo things and make mistakes, stuff like that. So in this particular case, the bash template's pretty involved. There's only 300 lines of code just to do the bash command. This gives you automatic code completion and all stuff. But while we're here, we should probably talk about a couple things. So one of the reasons that I'm doing this Go module right now is because I've already done it in the bash template. So in the bash template, I already created, I'm doing a bash coding today. So I code in bash and Go pretty much it. That's it. And web. I code in web stuff when I have to. I'm going to be doing a lot of PWA development pretty soon, progressive web applications development, including notifications and stuff like that, because I'm webifying the Zettelkasten repo that I have over the time. That'll probably be happening this weekend. I have a day with my wife and stuff, but this weekend I probably am going to be webifying my Zettelkasten repo, which is always, I've already got the code mostly done for that. I just have to tweak it and stuff like that. So that's coming. And you'll be seeing, if you want to see me do web development and laugh at me, you can do it at that time. So justifications, guidelines, legal bar, and anything. So this little section here, the reason I'm showing this off, even though I'm in the bash template and not Go, is because I want to add this exact functionality to the conf-go library. So I'm porting words from software development. I'm taking, functions and functionality from one language and saying, hey, I want to be able to do all of those same things in this other language. So I'm taking bash code and I'm porting it to Go, which is a very, very common workflow because bash is designed to do rapid applications development really quickly. God, I can code shit in bash. Wait, by the way, I'm going to swear on this stream. These are not like polished streams, so you're going to hear me swear. These are, so we're going to go all the way into here, and you can do stuff really fast with bash and curl and all those sorts of things, and you don't have to find the right library or anything. And then you can go right back. You can just port all that stuff right over to Go and then like really flesh it out. And that's exactly what I'm doing with my Zettelkasten Zet command. So I have a command called Zet, which is a Zettelkasten note-taking method, my method, my version of the method. And it's in bash. It's all in bash right now, right? And I'm going to write, it's not done. I'm going to finish writing the documentation and everything. It does all kinds of amazing things that I really like, including creating indexes and searching and everything with regular expressions. But it's not done, and it needs to have read. The usage materials got to be all written there. And then when that's all done, then I'm going to port that over into Go, and the Go will be the thing that I eventually release or apply to Y Combinator or whatever the fuck. I don't know. I have considered that. I just was reading about somebody who applied to Y Combinator and got in. I'm not really a fan of venture accelerators, but I we'll see. Maybe not. But so that's kind of the idea. So I'm only just telling you this idea. So the reason you hear me talking about bash and Go in the same mouth, same breath, is because bash frequently leads to code that I write in Go. And that's the way I think it should be, because bash is a scripting language very clearly, and bash and Go is a very clearly, an enterprise systems script engineering language. It's the language of cloud. Docker, Kubernetes, everything has been built in it. I don't have to justify using it anymore. So, and in the old, and this is the reason why Python, I'm not doing it in Python. Why? Because Python is a scripting language, but it's kind of like in between. It's kind of tries to be more than a scripting language, but it's really not. It's definitely not. Right? It's a scripting language at the end of the day. And it never really makes the jump over into an enterprise language, even though people use it in enterprise all the time. It doesn't really make that jump very well. And that's why Go was made, specifically to replace Python, Java, C++, and C. That was why it was created at Google. So my development style, and this is kind of ending up, I still got 10 minutes of kind of introductory commentary here. So my development style is this. I will get an idea. I will write the usage statement. I call it usage-driven development. There's probably other similar methodologies that are differently named, but that's what I call it. And then I like write down what I want to do, what I want it to do. How is the user going to interact with this thing? And even if it's a library, and this is somewhat difficult for me sometimes, and this particularly today I'm going to have difficulty with this because I'm writing a library, right? Well, who's using the library? Who's your user? You can't use this usage-driven development unless you know who your user is. Well, in this case, the user is going to be developers, primarily me. And so I have to write things like the API and stuff. But when possible, I like to even, go higher than that and say, okay, well, how would someone use an application that uses this library? What would it look like? And that's what this is. Okay, so this is something I've already done in Bash. It was already it's a generic configuration. So I'll just do a quick little demo within this first 9 minutes of what the functionality that already exists that I'm porting to Go. And that makes my project a lot easier. Also, this is really, really great because I already know what I'm building. I know it works. I've worked out all the kinks. So all I really have to do is make sure it works in Go. And I've got all the code done in Bash already. So, so there's no, like, should I do this or that kind of questions, because I've already done all that. So let me give you an example of how this works. So if I have my Zet program, so I have Zet config, and it gives you, this is all of the Zet configuration. This is, if you know Java properties files, this is somewhat similar. Java properties files are something, colon or equals something. And they have types and stuff, but this isn't. This is just two strings. It's a string here for the key, and it's a string here for the value. The end. That is all we're doing. That is all we're doing. In fact, I have come to despise and detest JSON for configuration files. There's no need. There's no need. 9 times out of 10, you're using JSON for a configuration file, and you've overcomplicated the configuration. Not to mention the keys. And so one particular thing, I talked about this yesterday, the one particular advantage of doing this way is because first of all, it's compatible with everything. I mean, this is compatible with awk and sed, for God's sake, and just regular old bash parameter expansion. It doesn't have to have JQ to do this. That is why so in my opinion, in my world, I like to do, progressive design, which means use the least of possible available technology at your disposal, and then add to it, layer on it, add as you need to. In this particular case, I don't need more than key value pairs. The end. First of all, Bash doesn't support more than one layer of key value pairs. It doesn't have maps of arrays and arrays of maps and maps of arrays, blah, 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 etc., which can get confusing for no reason. It's just keys and values, but you can still get the same sort of thing by just naming your keys in an imaginative way. There's nothing that stops me from putting a dot in the key name. There's nothing that stops me from putting a bracket even in the key name. So if I want to get creative and make my keys so that they get filtered, and people are like, well, what about performance? No, this is a configuration file. It's not being read a million times. It's being read once, and then it's being optimized into different places wherever it's needed, and then occasionally it gets read and written to. So it doesn't have to have really crazy high read and write possibilities. The more important user parameters for this, and I'm just kind of spitballing here, but these are the requirements of this project. The other one is I need to be able to edit the thing pretty quickly. So I just do config edit, and now I can go in here. It opens up my editor, and now I can go change any of the values, right? If I have a line return I want to include, I can decide I want to do \n, and that particular configuration variable will be used with printf or something that understands \n. As far as my configuration tool is concerned, and this parser, it's a / and it's an n. It doesn't care about the escaping. It's just text. It's all just text. Which, by the way, is part of the mantra, one of the 10 principles of Unix philosophy by what's his name, Dave, the guy who did pipes. I can't remember it, but is to do things as strings in text. It makes things faster. It's very Unixy to do that. And they're not getting bogged down in types and shit, because you can always cast something to whatever type you want later on. And so that's it. So let me give you some of the other stuff. So one of the other things this does is it automatically adds any of those configurations to my completion. So and it kind of combines them with my verbs, which can get interesting. But so if I just want to look at them all here, I could do this. I could do Z category, cat tab, category. Let's see, Z category. Wait, is that category dot figure? Oops, I think I need to do config, sorry. Yeah, so that says, I can look up the different configurations. If I want to set it, I just put a thing here. If I just going to access it, this is very much, this was inspired by Git. Git does this for git config. You get a value, it sets it. If you just empty the value, it shows it to you. The end. No, there's no fanciness there. There are a couple other things. I think there's delete. Let us see. Yeah, there's the key value. This deletes a value. This shows you all the keys. Oh yeah, I forgot that. So that config keys. So again, since this is in my template, any bash code script that I make that uses the template, it gets it for free without a dependency. So it doesn't have to like download or in source or anything. It's all built in. So the get command config values. So if I want to do that, Z config values. So this is one of the reasons I did this project first, because I already have it finished. I can demonstrate its behavior before we get into the Go coding version of it. Directory, get config directory. So, or Z config, dir. If you'll notice, I always provide a speakable version. In fact, you'll see me with my phone. Sometimes I'll grab my phone and I will speak the words that I intend to use in my command line into my phone to see if they resolve properly. For example, Zet. I found out that Zet actually does resolve. One time I was going to use daemon and instead of service, and Google does not pick that up when you try to talk into it. So I believe really, really strongly in natural language interfaces. I think we should. I think dashed interfaces are the devil. I hate Cobra. If you have to use it, fine, but I hate them because I think we're moving into a conversational user interface world in the future. I know it's pretty early on into that future. People writing applications for the command line they do not care about their interface being speakable. I do. So I refuse to make any code that I control not speakable on the command line. And there's lots of ways to do this, and this is why I'm doing this config module. If you start to eliminate, dashed options and arguments and all these different things, everybody says, well, what are you going to do about all these different varieties of things you're going to do? You know what you should be doing? You should be preserving state and then making whatever it is you want to do into multiple statements, just like you would if you were speaking to a human. If you're going to speak to a human, making developers' lives easier, not administrators, absolutely, nor users, right? So when we're talking about, you can do it. You can do it. You can make a conversational interface, but you're going to have to do it in more than one command. And a big piece of this is adding state. And how do you add state to a random command? You add a config module like I'm talking about. Because then what? Then when you need to add state, you should say, look, well, I mean, like Zettelkasten, right? It's like if I were to do zet commit, right? Instead of doing dash namespace like in a kubectl thing, I would set the context. I would say, okay, I'm going to set JSON or whatever. I'm going to set Jupyter Hub as a context, and I'm going to just use it that way. So to me, changing the state of your command application instead of trying to stuff it all into a single line is the way to get around this and to make conversational user interfaces and better user experiences generally. So I'm a big advocate of that, and I just want to bring that up since you see this here. I did go ahead and like give in whenever I have no problem making shortcuts. So because I don't want to type it either, but and whenever I make a shortcut, I make sure that there's a fully speakable version of it as well, so that they can say the whole thing. Or they can tab and get the whole thing. I mean, and God knows we've been doing that. I mean, kubectl has taught us how to do that. So the config path, this is the path. The path that's resolved, this is actually automated. And if there's anything that gets tweaked here, that might be it. So this automatically finds the config values. This is standard. And it follows the free open desktop standards and stuff, unless it's overridden by a home environment variable, blah, 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 blah. It follows all of those things, but it's done implicitly. So when somebody uses conf-go or the version in bash template, they don't have to think about it. They just have to add a configuration, and boom, it saves it to the right place, and it caches it in .config, and they can symlink that from their dot file repo on GitHub or whatever they want to do, and they don't have to fight over this. Like it or hate it, NeoVim, one of its things it claims to fame is that it finally put the configuration information under .config, like it should. Like, God now intends. God changed his mind. He didn't like all those dot files at the root level in your home. So edit is a thing. Edit is an intelligent sensor. It looks for your visual, your editor environment variable, or it looks for your generally configured editor for your application, and then it will open that up and then use it. So yeah. Let's see. Config. I think this file needs to go though. I can't remember. Oh no, I remember. If you provide the path, oh no, right. So this will give you the path to the specific file within the configuration directory. This here will open the file in the configuration directory. By default, it's values, and it doesn't have .json or anything at the end. It's just plain old Unix file, and then delete. Will delete a specific key. And I didn't put the key there. I think that usage is wrong, actually. So anyway, this is what we're making. We will be the question is, we're going to make an API that does this, the functions that do this, but we probably should make a command as well that does this. I already have one called command-config, and I'm probably going to be reworking my command-config to use this, but I don't know if I want to do that before or after we do the library. So we'll probably just finish the library using a test suite, and I'll show you how to write my version of test cases using nothing but the standard test suite, so you don't have extra dependencies and problems. And that's where we're going to be. It's been 25 minutes. I'm 1 minute over in my Pomo timer. I'm going to take a 5-minute break, and I will be right back, and we will get coding. So go take your break. Do what you need to do. Do 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 do. Okay. Okay. Yeah. If you need to do a Go installation, maybe have to ask me during AMA time. There's lots of ways to get Go on your computer, and they all kind of differ. I strongly recommend Go development for the command line. That's how it was originally done. It's still primarily the most powerful way to do it, in my opinion. If you're not going to do that, install Goland. You don't have to do anything else. You guys know about Goland, right? Goland is an IDE. It's way better than VS Code for Go development, specifically for Go development. Everybody swears by it. If you don't want to use Goland, you can use VS Code, and then you have to do all the crap to it to get it to do Go, which takes a long time. There's lots of stuff you have to tweak and everything. Same with VI though. So if you're going to use VI other way, you're kind of buying off on that. All right. So I'm a terminal person, so I like development from the command line because I can leverage Bash to generate code and develop code as I'm doing it. And you'll see me do that a couple times while I'm doing all this stuff. That's my preferred method. So tmuxin, it's an IDE and not text editor. Yeah, it's an IDE for sure. Yeah, I'm glad you drew that distinction. It's very important. Yeah, VI is in text editor at the end of the day. Unless you add, the operating system, tmux and bash with it. All that combined makes a nice IDE. That's what I use. So, I just tmuxed in. I'm in the middle of conf-go. So this is a new repo. I've already saved it to GitHub. I'm not going to cover that. That means it already has a .git directory in here. That's what, makes a Go directory, a GitHub, a Git repo is it has a .git in it. If you have a raw repo, it's just the Git stuff. It doesn't have the extra files with it, which is kind of fun. If you ever want to try raw repos, they're really great for backing stuff up. That's how I back up my private information and stuff. Anyway, and I started by kind of creating a boilerplate about this. I actually wrote about why I chose this form of organization in Zettelkasten. If you want to go look, so what is it? Zet chat, personal Go testing conventions. So there's my testing conventions right up. And I don't have my file outline here, but I could probably write that up sometime. If I might have it someplace. But it's my Zettelkasten. If you don't know about it, go follow that. It's rdbxrob/zet on GitHub. That's got all of my current notes and comments and rants and everything. Literally, they call it a second brain. It's literally everything I ever talk about. I post it regularly to Twitter. So if you Twitter, I post very, very frequently to Twitter, mostly notifications about what I'm doing on the live stream and here. Sometimes occasional comment, but mostly it's just a vehicle for notification. All right. So, I've already done my Go mod. So to do that, let me do that. I'll get rid of it so you can see how to do it. So the first thing that I do in any Git project, whether it's a command or a library, and you really only have those two options when you're making Go stuff, in a directory, anything in a Go directory is either, everything in the directory constitutes a package. Okay. So everything in the package in this case is going to be either, if you have a package, you either have a module is different than a package, by the way. So a module is, a single Git repo, essentially. Oh, I have a call from my wife. I got to take this. I'm really sorry. That's my wife, Doris. She's coming back from her mural art residency. She's doing art. DorisKapner.com. You follow my Instagram too. We're gonna be going out. We're gonna be taking lots of pictures of art this weekend. If you want to go hang out with us, I actually created another account on Twitch called rdbxrob.live to do that kind of stuff. I'm going to start streaming like live stuff if you want to watch. So Right. So we have this thing. So how do you start with step one, create a directory. If you want to create a Git repo that goes with the directory right away, fine. I usually do, but even if you don't, you should, when you're setting it up, I personally think you should imagine that it's going to eventually be a Git repo. And a Git module is a repo. Okay, so we're going to do Git mod init, and then you have to give it the name of, or anticipated name of, the place it's going to live. So this is where this doesn't have to be GitHub. It can be anything, but this is the URL that's going to be used for imports and everything. So and it doesn't have the .git at the end. So github.com, get rdvxrob, what we call it, conf-go. And not git mod, go mod in it. And then to have it get all of the stuff, go mod tidy. I don't usually do it, but whatever. So then you can look at your go mod, and it just puts the version of Go that you have, and it puts a module in here. And we're going to use this file for lots of other things later, but for right now, that's all it is. Right? There's no dependencies or anything. They would be listed in another file called go.sum. And I don't want to get into this. Go modules are the most annoying thing for beginners to learn. So you just want to work. So let's just add that. I went ahead and created an examples test file right away. In that Zet that I passed to you, I go into detail about why I think examples are the best tests to write. And I'm going to go ahead and start with the examples. So Go has many different kinds of test cases. We're going to use examples. So whenever you do, every single file that's actual Go code at the top must have a package line. So you put package, and in this case, I'm going to call it the name of the package. So in this case, it's conf. Did you read the title? I'm going to give you shit if you don't read the title. Package conf is the name of our package, right? Now, here's something crazy. We're going to actually put underscore test, and this is a convention that says if you put underscore test in there, we're learning how to program in Go. So that's what we're learning. And the rest is up to you to research what that is. So package conf underscore test. And that says that anything in here is going to be treated as if, it were being imported from somebody else's remote repository someplace else. So anytime you want, when you're doing tests, if you leave it off, then you can use locally scoped things. So everything in the same directory is all as if it were all written in the same file. That's the most important thing to understand about this. And that's all good. But if you have a couple of files in there that you want to, like for tests, for example, and you want to say, okay, so this file here, yeah, sure, I want it to be included in the module and everything, but I want the code in it to pretend like it's written someplace else, has no idea that it's a part of this package inside of this file directory. This is inside of this directory. So we put underscore test. So then we do import. I could import a bunch of stuff. I'm not going to import anything right now. I'm just going to do standard library. So the example tests all start with the word example. There's a bunch of conventions here. It uses reflection, if you know what that is. So func example, and we'll just say simple, right? It doesn't matter right now. And the really great thing about examples is you don't need anything else. You don't need anything in here. You write that, right? But an example has to have the word output. And it's just one of the coolest things about Go. It has to exactly be that. If it's not that, test won't pass and you'll be annoyed. So just put foo here for right now, right? So that test is gonna fail. I'm gonna open another window to test this. Actually, I'm gonna open I want to open one over here, and I'm just gonna run the tests over and over again. So this is a little bash script, series of scripts that I write that detects any changes to the directory and reruns the tester. And so it's my version of testing. So if I make a change here, anytime I see a save, see it'll like blink, and that's because it's reevaluating. Now, this is the annoying thing about streaming right now, because I cannot see shit because y'all are on the screen and I'm trying to keep my fonts big, but you see that it failed, right? Because it didn't get the output I wanted. But if I wanted to make it pass, I just do fmt println, and I say I want to print foo, and now it writes it. Now I don't know if you noticed that, but when I saved it, my Vim-Go plugin, which is essential if you're going to do Vim development with Go, it automatically imports. It's actually Go PLS or Go imports. There's a number of tools. I'm not going to get it. We're not doing setup today. But what it does is it automatically grabbed FMT. Go will throw an error at you if you try. See how it got rid of it? If you don't do that. So one of the most mandatory things to have in your development process, I'm telling you, is you have Go imports or whatever equivalent you want that keeps you from removing that import line, because it will annoy the hell out of you. I did Go programming for at least 2 years before setting that, and I can't believe I did it. And now it just resolves it automatically. So now I'm passing, right? So an example test is really simple. You have a commented line that begins with the word output, lowercase or uppercase. You can have unordered output if you want to, so like the order doesn't matter. And then if this line matches the stuff that comes out of it, you pass. The really great thing about example tests is that when you do Go docs, so was it Go doc? Go doc dot Go doc. I don't remember it. I think is that it? Of course, Go doc on directory no docs. I don't know how to do it. I haven't done it in a long time. Is it Go doc or Go tool docs? Go tools doc. Anyway, Go documentation will, and it looks like I don't have it installed. Go documentation will automatically give an example. Let me show you. So, yeah, let's open this back up. And wait, I think we have it open already, don't we? Yeah. So if you go, let's go back here. Whoopsie. Where is it? Nope, that's not it. I'm trying to find one. So if we went to, I'm trying to show you documentation automatically so you can see what happens. rhrob/config. No. conf-go. And you can actually click on the documentation link, and I put that in my README here. So if I go to the Go reference page, go.dev automatically finds your Go projects. You don't have to register them or anything. It just finds them automatically on GitHub based on looking at what's in them. Super cool stuff. And it tells me, here's my README file. It gives you the overview. And it has, remember the examples I was telling you about? Yeah. Well, you can click on documentation here, and this is all of the stuff that is in the previous one that I'm going to be porting. And I don't think this one has any examples. Nope, it has all the types. It has the types, but it doesn't look like it has. My point is that this documentation, this embedded docs, it's all written in the documentation. The example will be here, and it'll actually be runnable. They can usually click on the playground and go play it and run it. So that's what's up. So if we're going to do test-driven development, we should probably start writing how are people going to use this thing. And I'm not going to write the test for that. I'm going to actually start writing the usage statement for that, which means that I'm gonna zoom in here, and I should put my S keys on so you can see what's happening. And then so I've been rewriting a lot of this. Go conf. So this is what we're building. A lightweight configuration directory. I need to set Pomo again. Yep. We got 25 minutes. Let's do this. Rather than do JSON keys, all the stuff I told you, the legal stuff, that's all good. So now we should probably do a usage statement. But in this case, I don't necessarily need to write the usage in the README. Why? Because the usage is what the variables. I mean, what is the interface going to look like? So let's go ahead and just write that in code. So we could write it in the examples and say, okay, I want to be able to say this, and this should give me this, right? And I mean, I kind of could go either way on this. So what do we want to have? I'm kind of crossing the fence here. So I have a convention, I name it lib.go, just to tell myself right away, this is a library and not a command, a library package that is. So, and then we need to actually write a function. So let's write a function here. What is this function going to do? Well, let's go back to the other one that I had. Let's go back to the template. Remember the template thing, and see which ones I want to do there. You know what I can do? Let's just do it from the command line. I don't want to do here. God knows I like the template better than the command line. Let's open another window, and I'm going to go into the bash template. I'm going to go look at it. And I don't know if you noticed this, but watch very carefully, all you Z Shell fans. I'm about to CD from some random place into some other random place. This is not so random because I have CD paths set that most Z Shell people don't know about, who bash on bash all the time. So, okay, we're going to do this. I had to throw that in there because people don't know. All right, so config. Here's all the internals that implement the configuration thing. It gives all the documentation as well. That's all great. I could probably all rip this documentation straight off and, just do it, right? So here's our commands. We need to make these commands. What should we do first? Well, we should probably do config path, config-dir. It depends on config-dir. So let's see, where's config-dir? So again, we're doing a port, so I kind of could cheat and see which ones I already have working. So this is all bash code. So as you can see in the config-dir, it says by default, set the home directory, set the current directory to the user's home directory .config, followed by the name of the executable. And it can be detected through just looking at, I'll show you how to do that and go in a second. And so that's the default. And then it says, if there is an xdg config environment variable set, then this is an if then, but it's called a short circuit logic. So it uses and operators. The way and operators work is that they're evaluating conditions, and it doesn't proceed to evaluate each of the conditions unless the condition is true. So you can therefore use it as a shortcut to avoid writing the if statement at the expense of clarity sometimes. So here we have it's called short circuit logic. And so we do this here, and then we go here and go and dir equals blah, and then /exe. And then we have, so this says, okay, set the directory to that if we have it, right? And then it says, okay, if I have a config directory, override whatever the other one is, and then that one wins. So this is one of these last wins kind of logic trees or descents. And then over here it says, okay, well, if I was given an argument, then that argument wins. Now you could clearly have written this logic much more verbosely with if statements, and in Go, we are going to have to. But I want to show you an example of why Bash is so phenomenally awesome for rapid applications development. Because the amount of time it took me to write that is nowhere near what it's going to take me to type out the stuff we're going to have to make. So let's do this one first. So the first thing is we need to, let's call it dir and Go. All the functions have to begin with a D if you want to export them. And because we're making a usable, library that other people are going to want to use, that's the point of usable, then they're going to have to type, we need to export it. So we put a D there. We don't put export or public or any of that. We just do the, if we want a private, we put a lowercase d. That's it. That's a Go thing. So we do func dir, and then after func dir, what do? We do, after func dir, do we have any inputs? Yes, we take one argument, and I don't know what we're going to call that. We'll find out. Oh, that's the name of the file. Okay, so then we take one argument as the name of the file. So this is, I have a little bit of a dilemma here. I sometimes will write the documentation before I write the function, and then I end up changing the function, and then the documentation is a waste of time. So I go back and forth on this all the time. I flip-flop constantly. Sometimes I'll write too much docs, and then most of the time, though, I end up finding that I'm writing too much. I end up writing documentation, and it helps me get my head around what's needed. And then I don't mind throwing the documentation away if it was wrong, because it was part of the thinking process. But I would rather have just talked it out, like with you guys, you people, and then just done it that way, right? So if I do a func dir, and I'm going to have to take an argument. Okay, so this is the thing that blows people away who've done any kind of other programming in other languages, except for Rust, which is the same thing. we're going to name the directory the argument first. So let's call it file, because we don't care. Actually, they tend to use one letter. It depends on how much you got going on here, but they tend to use one character as an idiom, and Go is they tend to use one, but if it's a string, then we make it longer because we want to give some sense of what it is. But if you have a type over here that's very explicit and it says what it is, then usually they're more likely, for example, if you had a context, which I fucking hate, context.context. I actually opened an issue on this and got shut down. I think that's annoying as hell, right? So why would you name it like that? This is an actual thing that you're going to see all the time and Go. So instead of that, the convention that they've decided on is CTX, right? Or even C, right? Because you know what it is. So anytime you see a C in this block, and as long as your functions don't span a single or more than a screen and a half of code, which they never should, unless you're writing a compiler, you're writing a recursive descent parser that's going to span like 600 lines for efficiency. You have no business making functions that span more than 2 or 3 screens, in my opinion. People do it all the time. You want to see really great C code? Go read the C code in the kernel. Most of the C code in the kernel is like tiny. The functions are super freaking tiny because you have to. At that level, you have so much complexity you have to hide. So they don't write big, long functions. It's really bad because then you can't swap things out and all kinds of stuff. Anyway, so we're not going to do that. We need a string here. So we're going to name the string as a file, and we'll just put the name. So we could say file name. Things like this are belong in C++, right? No. Another thing too is that if you are going to do that, the convention is mixed case. I try my hardest to never have to have 2 words in any identifier unless it's like a function, because I freaking hate doing retyping long identifiers constantly. It's annoying as hell. I hate reading C++ code because of that. Java's even worse. So these are some of the reasons that I really love Go. So functor. So what do we need to do? We take in a file. Okay. So if we have a file, we have a file. If we don't have a file, we don't have a file. Nobody cares. So, okay. The first thing we need to do is come up with the directory. So we're going to need to read an environment variable, right? So we're actually not going to do this all in one shot. We're going to break it all down. First thing we're going to do is say, I want to look up the home directory. So, and I'm going to do a search for this. I know how to do it, but I'm going to search for it. Go lang, you have to search for that. Look up, is a single word nowadays? No. Fuck no. Not in Go. The file name I think is written as a single word, but I'm not going to, no. I'm just putting file. File or name, but not file name. Too many letters. I'm sorry, I refuse. Go lang, look up user home directory. Now here's where we're going to get some bad information. Yeah, there's some bad information out there because they've changed Go recently. Still too verbose. F for N, right? C coders. So getting AV home. This is a huge mistake. This is a fucking huge mistake. Don't do that. Don't do that. Don't do it. This is one of the most annoying things about this. This answer on Stack Exchange is wrong. And there's lots of wrong answers. First of all, to be fair, if you want to get an environment variable, that's what you do. But that's not going to work on Windows where there's no home environment variable. And the whole point of Go, one of the main points, is to write cross-platform blank code. So why would you do that? Now, so let me just say, I did it on purpose because I want people to know that when you're coding in Go, you should be looking in the standard library as frequently as possible. All right. So I'm going to do that. I'm going to say golang doc going. I happen to know it's called OS. Let's say golang OS package user home directory. So you don't take the first answers, people. A lot of times you have to go, here it is, the user's home directory in Golang. Okay. So this is actually the right answer. And it's going by example. This is one of the many sources. I think this is actually changed too, though. This is pretty old. I think this was actually, no, I'm confusing it. There's another one that we got to be careful on the next one. And I'll tell you why. So it gets the current user, and then you get their home directory, right? This is the right way to do that. Now, obviously, do you remember the whole RAPL applications development spiel I did about Bash? This is not as easy as Bash. In fact, it's usually at this point that you'll do something like this. You'll create a new directory called, you'll say, I want to get we'll say like home dir, right? We'll just say home. I mean, I'm whatever. Because we're going to be calling it all the time. So then this is a very C-like thing to do. So then we take all this code, and I don't care about, I know how to use this code, so I don't care about cutting and pasting. That's not a violation of any, principle I have. So user.current. Now you have to check whether there's a user, because there might not actually be a user. So you have to check, and then you have to log whether it's failed. You can log it or not. Logging errors is much better than panicking, by the way. So, and then it says the home directory is user.homedir. And we don't have to do that. We can actually just do this. We can just do return user.homedir, which I think is a string, but I don't remember. We're going to go see. It's going to yell at us right away. So we're going to say string. So we're going to, that says I'm returning a string. I'm returning a string for the home directory. Oh, it's great. Hi, Dennis. So we have 13 minutes left, and we know how to do this. So this says, this grabs the current user. You have to decide whether the error is standard. People have suggested that you can or should name it something else, but don't. Just don't. It'll just confuse people. So then, okay, well, now we got a function. I got this other function here. So how are we going to test our function, right? Now, I believe strongly that we should actually write test code if we're going to write something like that. So let's zoom out again. So we got our test over here. And so this, however, is a private test. This is not a test of something that's going to be shown to the user. So, I can do it there now. This is where we start to get into really hairy test waters. I mean, again, we're trying to port like a 5-line bash command that would have been done in 30 seconds. But we have to write all of this shit in Go if we're going to do it properly, right? Because we have to test it. So now we have to do func. And so this is a local test. This is not an example style test. There's no underscore test. I say func, and it starts with test now. Test, and we're going to do test home, which is a function. And in this case, we have to do t, and we just make it testing.t, which you just have to have. That's the test object. And t.log, it's got a whole bunch of stuff. We could just say yay. and it should actually, we didn't do my tests don't have verbose on there we go. So now we get it. So you see yay, you can see everything, right? So this is we're gonna run the home directory. So then we do this. So we say, I want to check my home thing out. So I'm gonna say h, I guess, equals home. And oops, this isn't C or Perl or something. And h declared but not used. Okay, that's fine. And then we log h. And this is some of the extent of some of my tests. I kid you not. You tried Endeavor? Did you like it? Actually, Endeavor really looked pretty to me. I'm interested you tried it. Yeah. So in code coverage, believe it or not, what I just did counts as a test. It'll cover it. It counts coverage, but it obviously is not covering it, right? But I can't write further test cases and have it be for everybody, because why? Because if I try to test it against my hard-coded user ID, somebody else is going to test it in their platform. It's not going to work unless they encapsulate the entire test environment in a container and then run it in their test container that has a set specific user. Do you see why people write code in Bash? Because to do this properly, just this little utility, I have, to do this particular little tested utility, to get a consistent test, you actually have to write a consistent test framework and a consistent test environment, which is why you see developer-driven containers all the time. Yeah, but don't tell it to your boss. Right. So when you do this, now I just totally cheated and got custom coverage just by using t.log. But strictly speaking, if you wanted this to be compliant, you would create a container that had a user in it that was a consistent user, and then everybody would run that and it would test them all the same every time. That's the proper way to do this. If you're going to do it long term and you're going to make a big project out of it, in which case you're going to be re-examining all your tests anyway, right? So I just want to make sure that I called it right. And let me just take a moment to say, why would I do this, right? Well, what's the alternative to seeing if your code even runs? Think about it. If you're a C developer, right? If you're a C developer and you want to test your function, what do you have to do? You have to write another bit of code that calls the function and just compile into that thing and then print it out and check out what it prints out. So one of the greatest things about Go's built-in test environment is that it gives you a way to run code even if you don't plan on doing any exhaustive tests. If you're not going to do any exhaustive tests, then just print out what it does and see if the thing runs. It's essentially the same as print statements and shell. It's the closest thing anyway. And one of the reasons I really like Go is because it fits at least partially in this middle space between, a really exhaustive test framework and language that really needs it. It's external from the language, and it's built-in testability within the language that I just want to run it. Okay, so that's one of the biggest advantages I have for I got this code off the internet. I didn't know if it worked. I'm gonna mess with it and tweak it and see if I just want to see if I got my spelling correct, right? I've got to do that. I've got to do at least something like that. So there. Now, by the way, while we're at it, if I wanted to isolate the test, I would do run, and then you use any Perl PCRE, Perl regular expression to tell it what tests you want to run. So then you can just say home. I only want to run the home test, right? So I don't think it ran it. Yeah, there we go. So now it's only running that test. Now watch what happens. If I add another one, if I add another test, so we'll yank all this, and I do foo, right? And I do t dot, I can do t dot fail. It still passed. Why? It passed. It passed because I told it I only want to test that one thing. And just so you know what God is. Hey, how's it going, Anon? God is just running. I'm not gonna get into it. You're gonna have to read it. I don't want to explain it right now. It's just a bunch of shell scripts that run go test. The end. That's it, and pass the arguments. So you can see now that ran both of them. I can delete that out, and we're good to go again. Again, what was the reason that I did this in a separate file from example? Because I don't want testing my private stuff in my examples. There's no need. I should have an example that's indirectly going to test that, which will probably be, testing the external thing. So lib.go. Let's actually do that, right? So we have home, right? So let's test this. So the first thing what are we going to be returning here, by the way? So the directory is going to be returning a string, which is a path to the directory. We're sticking with strings for now. That's screen key. So we're going to call home, and we're going to say, I'm going to say home equals home. Because I don't know, I probably need to cache it. I don't know. You think we need to cache that? Probably. I think we need to cache it. Do we ever need to use it again? We have home, dir, home. No, we don't actually. Well, we'll leave it in there because we're gonna compose the path later. So I probably can get away without using it like this. Let's do that. Let's just that. Let's return home because it's a string, right? So now we have a test, right? So now it's probably time to make our example test. Examples. We're going to go say, we need an example, not simple. We need to actually, this is a public example. I want to say, no, I want This is going to be a demonstration of how to use, which is why I use white space and stuff, because people are going to read this. They're going to actually read your code to sit here. So you want to like make it pretty. And the hard part here is that I actually can't test it for all the same reasons we just mentioned, right? So unless I'm going to do some sort of weird test. So this is hard because it's gonna fail, right? So let's try it. FMT println, and we'll say conf.dir, right? And you see what it did? Not enough arguments to call the conf.dir. All right. Well, we're gonna say, oh wow. Okay, so we just found a bug already, right? We have a bug. The bug is that we want a variadic function signature. Does anybody know what that is? Raise your hand if you know what a variadic function signature is. Raise your hand if you know what a niladic function signature is, or function return values. So what this means is that I have to do make this optional, right? Now, maybe I don't want that. Maybe it's actually doing variadic function signatures can be a problem. Python people do it all the time. JavaScript people do it all the time. And C coders don't like it. PHP people didn't like it for a long time. And it can be a bad practice because it makes it a little unclear by looking at the function signature what's expected. Now, in this particular case, I'm inclined, if I were going to, so let's think about this, right? So you hate it, right? Yeah. And so, because I hate it too. So the more idiomatic way to do this, the more idiomatic way to avoid variadic parameters, which turns it basically into Python, is to make an additional function that does exactly what you want. Exactly. Rather than having a bunch of options all coded into a single function. Then people in C fucking hate that. They hate it because you can't get what you want, which just makes your code inefficient because there's a bunch of branching and stuff. It's also one of the reasons people hate on the NM interface and Go. A lot of C coders hate it because it causes them to branch on the type and do all kinds of different things. So, which is why they're fans of generics, which is going to get around all of that. It's one of the main reasons they want it. So anyway, let's try this. So rather than using dir, it looks like args hides the brains that aren't mine. Yeah. So let's actually add something here. So let's say rather than dir, we'll say dir file. Okay. So and that the only reason I'm putting dir on there is because I want it to appear next to dir. I want it to be sort of a different option that you can do with file. Okay. So then I put file string. And this returns a string, and this is going to return. It's very C-like to do this, by the way. So return home, which we don't need to care whether it has something in it. If it's blank, we're going to do it anyway. So really, what we do, I'm going to do it wrong, and then I'm going to do it a better way. This is how you might write it if you're a Bash scripter, or a Python programmer, or a JavaScript person. This is the wrong way to do this. So you do home / and then we're going to write file, right? And it'll take it. We can even test it and everything. Let's do that. So, you notice it doesn't matter where the functions are because everything gets hoisted. It doesn't get hoisted at all because it gets compiled, but it's fine. It can go anywhere. And some of this stuff will probably end up in its own file. In fact, let's just do that right now. Let's call utils. I know some people get really uptight about the word utils. A utils file, people's utils files grow to be like thousands of lines long. The utils doesn't matter. The utils is just stuff that everything is going to use within my system, right? And there's going to be many things I'm going to be calling home, so I'm comfortable putting it there. But it's generally better to have a better file name for that. But that tends to fit that name for me. There's no rules about that. Oh, it's time for me to take a break. I'm going to be consistent on this. When we come back, we're going to test our new one. I'm going to show you how come this is a bad way to do this and the better way to do it in a cross-platform method. But that'll have to happen right after I come back. See you. My wife just got home. She just walked in as soon as I had my break. All right, so where were we? I like having a break like that because it actually gets me back on where we were. All right, so now it's time to test this different thing. Let's write the test for that. Again, this is not rapid applications development. There's nothing about this that's rapid other than it's not as fast, as slow as it would be in Java or some other language. And okay, so we're gonna go back here and let's change this into conf-dir to dir file. All right, yeah, this is gonna be Rust and this is gonna be saved. I'm gonna do all my development stuff saved. This will be all under the same project. And so we have fmd println conf-dir, right? Dir file. And now we know we need to give it a file. So let's just call it values. All right. And then what we get? We get example dir file. Did it print it right? No. This is what it printed. It printed out that file, which is nice, right? It's not what we want, but if I wanted it to pass, I could do this. As you can see, this is going to have problems because RWX raw is not going to work for somebody else's test. You know, again, that's that problem we talked about before about having to set up your own test environment with everything. But I mean, we can leave it right there. One of the things I'm going to tell you something I probably shouldn't. One of the things that I do is I leave in example tests like that and I comment them out because I know that it did the testing and I can come back to it later, right? So another thing too is I tend to leave the lines off because actually I forgot about that. Since we're doing Go, we have another couple things in VI to use that we don't normally have. One of them is since we're using Vim, we can use instead of like DAP for a paragraph, you can use Y and D. You can do DAF, and it will grab the whole function, including anything because it is using LS. It actually knows about the syntax of the file and it can know what a function is because of the language syntax server stuff. So I'm not against people ask me all the time if I'm against LSP or whatever, and I'm saying no, I'm all the way for it because that allows people to define languages without using regular expressions and stuff. They can use actual parsers that are intelligent and they can do the right thing. So I'm a big fan. So we're gonna do that. We can say make this, values and that should actually pass. Not enough arguments to dir. Oh, right. We need to change that back again. So, and people ask me all the time, why do you close files and reopen them? And they said, because it doesn't take me any time to do it. Like, yeah, but it's like so much wasted time. It isn't. Sometimes I'll have it in a different window. I'll have the testing going on in one window and I'll have another, which is probably the way to go do this. Let's do that. So another thing, but with files of massive sizes, oh God, I would just learn regular expressions and then it doesn't matter what language you would in. So here we go. So let's make this the test, I guess, the test window. So got-v. And over here, we'll do our test. So we're failing our test. So then I'm going to go bang, bang, or whatever, A twice. And I'm going to make a new window. And I can even name the new window. Let's do the name of the window. Let's say, I'm going to say code or something, right? And this other one over here, we could say examples. How about that? So, you can, Tmux is awesome. You can do examples, right? So now I can I know what's up. Right. And I don't know what 2 is. What is 2? Oh, 2 is, we'll call 2, bash. And we'll say that's our bash template. Vim. And so yeah, we're going to go back to 3 here. And then this way I can just kind of work right on Go. So we got our 2 things. We don't want this anymore. We don't need it anymore, right? Now, so here's another thing we could do. Why do I have to use home here, right? I can actually do a recursive thing and I can say dir because it's all going to get compiled. Doesn't matter. It's not slower by any means. So I can do dir plus file, right? So now the only thing that uses home is this guy. And now how did that affect our examples? Ooh, hey, look, we're passing everything now. Nice. So we're passing all our examples. We're not talking about Rust right now. So, I don't know. Yeah. I'm not a Rust fan, but let's not bag on Rust right now. All right. So here's what we have. Why is this bad? Do we have Go programmers out there? I'm doing this really slowly, but this is bad. Why is this bad? Strictly speaking, it's kind of okay because Rust kind of makes up for it. But why is this bad? It's bad because we don't always know, strictly speaking, that every operating system that's supported by Go is always going to use a slash as a path limiter. Now, that said, Go is really, really good at translating the slash when you're dealing with things. But if you want to do it in a better way, you can do it with something called path.join. And you just put what you want to join, and you put the stuff in there, and you're good to go. Okay. That will automatically join the path. That is the proper way to create a path. Let's see if I still pass. Yep, I still pass. If you don't do that, you're doing it wrong. And I see code that's wrong all the time that uses plus with slash and everything. They're writing it like JavaScript. And even, by the way, even in JavaScript is a bad idea because you're supposed to be joining in things. So, or Python, right? A lot of Python people know this. Python, there's an equivalent in Python. So most Python people know how to do this right. But yeah, so yeah, path.join, right? So, and if you're doing Python, you definitely know it. But it's the same. It's the same in both. Okay. So that was a lot of work just to do one tiny fucking little thing. And I told you I was going to swear on here. I hope you're not surprised. Pomo start. And what were we working on? So we're going back to the bash code that we're porting. So all we did is this. That is it. That's all we've done from this function so far. Nobody would call this rapid. I mean, even if I was doing this without talking, it would not be rapid. Bash is for rapid applications development. Perl is for rapid application. But not even Python is good for rapid applications development. You know why? It forces you the same stuff. Short circuit logic and things like that, you can do it in Python, but people don't because it's not idiomatic Python. Why? Because they're trying to make the Python into systems language, like, or an enterprise language, which is, it has no business doing it because it's a scripting language. So keep your, anyway. So what? We got a config here and we need an exe. So we need an exe. This is also using top-down recursion. So whatever one wins, the last one wins. We're not going to use top-down recursion because, I guess we could. Let's try some top-down recursion. I'll try it. We'll do it this way. So we have to get our first directory though. So our first directory is this. Top-down recursion is a little bit of a waste of time. We might be able to make it faster. Cloud services, scale. Yeah, they can. Not really though. Python scales better, but it doesn't matter because you have to keep it. At some point, you have to leave Python to scale properly. And people will disagree with me all day on that, but I don't think Python is an enterprise large space systems language. There's lots of like million-line code bases that are in Python to disagree, but we abuse. Like I'm not going to get into it, but sometime in the late 90s, early 2000s, the entire world realized that dynamic languages allowed things to be developed much faster. And so that was when Perl came out. People were writing enterprise code in Perl. This is how we got thousands and thousands of lines of enterprise Perl that should have been written in a much more robust systems language of any kind. And they ended up being written in Python and Perl and Python because they could be done more quickly. And Python got, kind of kept around after Perl's still there, but Python kind of won because why? Because Python was more enterprisey. It was closer to Java or C++ or something like that. The truth of the matter is that none of those fucking systems should have been done in Python or Perl. They should have been done nobody wanted Java because look at the options. You had Java, C, C++, Python or Perl. There was no middle ground between Python and Perl, and that's what Go is. That's what Go is so good at doing. It meets that nice sweet spot right between there, being a real language, a real systems language that's compiled and cross-compiled and blah, blah, blah. I don't know about Java. But so anyway, enough of that. I mean, we yeah. But yeah, I agree. It absolutely is. It absolutely is. And so anyway, so I'm having a little moment of design quandary right here, because if I use the same recursive, when logic, then I might be wasting some processing power in the process. Now, normally I'd be like, fuck it, it's Bash. I'm writing it fast, right? But because I'm making, the final version of this code, I don't want to prematurely optimize. That's the root of all evil. But I at least want to think about the logic, right? So the first thing I'm going to do is directly translate this logic. So the first thing we're going to do is we're going to create, first of all, I have to get exe. How do we get exe? Well, where did that even come from? So exe is the name of the executable. And I'm going to go find you how I got it here. It's a standard thing that I have in my Bash template. It's super easy to do and cut. This is a good example of parameter expansion. Look at that shit, man. If you put base name in your scripts, in your Bash or POSIX code, actually if your Bash code, no, because it's supported in POSIX. If you put base name, if you call out to base name, which is a separate executable in your shell code, you're an idiot. And I was an idiot for 45 years. You're an idiot. I can't believe I missed this. I can't believe I missed this whole time. This here is Bash. We're switching gears here. But this here is exactly the same thing as base name. Exactly the same. Yeah. So here we go. So this says take $0, which is the name of the current executable, and strip everything off of it to be just, just the word at the end. And so we're going to try that actually. And we're going to do that. We're going to do a little bit of that. So how do we do that exact same thing in Go? Well, it's not as easy, right? Sounds like a utility though to me, don't you think? Yeah, so let's add it in the utilities. So we have another utility. We need to get the exe. So this is actually not as hard as it sounds in Go. In fact, I'm going to go read it right now. I know it's in OS. See, this is the thing. I'm going to do a search as if we didn't know, okay? So go lang, get the base name of the current executable. I know how to do this. I'm just showing you how I would search it so you can search it out. os.executable. There you go. There you go. First hit. Now, it's a Stack Exchange thing, so I would want to check on this, make sure it didn't get deprecated or anything. What? No, a better way as follows. That is not, oh my God, it's so wrong. That is so wrong. Since Go and the answer is os.executable, similar to other languages, is also os.arg0, is that OS executable is guaranteed to return an absolute path. So that's what we're going to use. You see how fast I found that? Didn't need code completion or anything. So we're going to say exe. I'm going to call it the same thing because I want to. Because what am I going to do? I'm going to strip that thing. All right. So the exe is going to be os.executable, which I assume returns a string. Yeah. So we're going to say ABS path because I like that prompt to remind me. And then we're going to take the end of it. We're going to split it. So for right now, I'm going to go ahead and just return that ABS path. I'm just going to return it for now and we'll go test it. Let's go back to our example tests. Nope, we have to add this to our, how about our lib test needs to change, right? Yeah, this doesn't belong in there anymore. Nope. I'm just to move lib test to utils_test.go. How's it going? So utils_test.go. Save this. We're going to copy this baby and do test exe. And we want to do exe and say e and then say we're just going to log it. I mean, I didn't even need to do that. So two variables. OS executable returns two variables. Okay. I was wondering that. Mostly, it's very, very common for things to return two things. So I'm going to have to do this thing again here. I usually have that as a macro. I don't have it right now. But that is what you would normally do. So you put this up here. So yeah, I'm going to be, I'm actually going to do this differently. Yeah, I'm going to do this differently. I'm going to say that it's either going to be empty or I'm going to use a nil thing, right? So, because this is going to be an empty string by default if this gives us an error. So I'm just going to dismiss the error. I don't need it. All right, so that's fine. So there you go. Look at that, man. Look at that absolute path. You see that? Wow. So that's the absolute path. But we just want to get the file name itself, the executable name. And this is actually extremely hard to test as well because your test suite builds a compiled executable that you can't really tell. Exit the program. Yeah, I don't want log fatal. Yeah, I think it's just as bad as panic. I'm gonna get rid of that. You're right. You're right. Let me think about home. No, I'm gonna do the same thing with home. So, I'm overriding this. Okay. So, I'm overriding this, and I'm gonna make it. So this is something that I like to do in my code. Not everybody likes it. There's some cases where if I'm returning a string, I return either an empty string or the value, and then I document it that way. If it's empty, if it's a nil string, it's called, that means there was an error and we weren't able to determine it. And you have the whole null thing, the null situation that you have like in database programming, right? It's like null. It means we never check it. Empty means no, we checked it and the string is an empty string. That is the actual value. But in my case, I'm going to do kind of a shelly kind of thing here. So if I have an error, I'm just going to return an empty string. Now, and I just have to know that about my function, right? But that's way better than fatally crashing my program by not having the right thing. That's a no-no. Don't do that. Don't put panic or anything in there. Oh, right. That won't work. Not now. Yeah, this will work now. So, actually, you know what I could do? I get rid of it completely and do, yeah, let's do this. We're going to return, so the default is failure, and we'll do if user equals nil, return, wait, does not equal nil. I mean, I can go either way. If user equals nil, return empty. Otherwise, return user.home. Sure. All right. Another thing too that we could do here is we could actually look up all this stuff in a init so that the values only have to be looked up once. And that is a kind of a trick to get performance-wise. But if your program runs for a long time and potentially changes effective user ID and stuff like that, that would be a problem. So I don't want to put that in there. What is it? Dirham? What did I have there before? I don't remember. Golang, /user. I forget the name every time. Where is it? Oh, wrong thing. Homedir. Yeah, it is. That's it. That's it. Oh, it's not a function. I see. There's a structure. Yeah, thank you. Yeah, sorry. Thanks. I just barely realized. It didn't take me too long to figure it out. So user.homedir is what? We got it. So we got it. We got everything. Exec. I got our executable path. That's all good. So we need to actually truncate this thing though. And so we're going to have to do path.split and I think don't they have a base name? Is it base name or base? Is it base? I'm just guessing. I have to go look it up. This is where, oh, it is base. Huzzah. So that's the equivalent of base name. And so that parses it off and just gives us a base. So now I have my AXE function, and my AXE function is being tested. I assume. Right? Do we have it in here? No. So, ooh, you know what? This one is actually consistent. I can actually write a test. So you can say if E equals conf-go a test, which it always will. You can't use single quotes in Go. That means something completely different. You got to use double. I screw that up all the time. Oh, right. What am I doing? So if E equals conf-go equals test, then T dot pass, what is T dot, no. I mean, I'm using the simple things. I don't care. Pass undefined. I thought it was fast. Pass. I think that's implied, right? Yeah. All right. Been a while since it does. All right. So that wins. Single quotes are chars. Yeah, they're runes specifically. Runes are different than chars. Chars and runes are totally different. Runes are Unicode aware. Chars are just one byte. But yeah. So one of the greatest reasons that Go beats C is the whole Unicode awareness. It's just fucking amazing. All its for loops and everything are all Unicode aware, and it detects whether. And if you cast as a byte string, it'll treat it like a byte string and do what you want as if you were doing it in C. Super fucking awesome. It's all built in. It's just great by no less the creators of Unicode, like the primary people who ended up creating the final specification for Unicode, Rob Pike and Ken Thompson, and they you know. Yeah, I know. Actually, I don't wonder which came first. So you know, yeah. I'll do with STL and C++. Yeah, you can do that. C++ is STL for that stuff. Not a fan, but you could definitely do that. What am I on? Examples? Yeah, so examples. And then we got that. Is on exceptions go? No. Fuck no. I hate exceptions. They push off the they've been proposed like 3 times, by the way. So they push off problems that you need to deal with earlier in the code. And so you have to scroll all the way down to the end of the code, and then stuff happens and it's like, I fucking hate exceptions. I hate them. And I, you know what, if you like them, you're probably a wonderful person. I'm not attacking you, but I fucking hate exceptions. I've worked with exceptions for a very long time in Java, and in not so much in C++, but in Java and in Python a lot. And I hate them because people inevitably write code that's too long and puts it all the way at the end. It's impossible to follow. And you have no idea what the problem was. You don't even know where the exception was thrown. You have no fucking idea. So, you know, people complain all the time about if null equals error. You know what? At least you know where it's happening. You know what's happening as you're going. That's imperative. Like step. If you put off all of that, how are you going to follow the code at all? So I don't like it. It makes the code easier to read, but it's mischievous, right? Because it might be easy to read, but it's not the whole story. They definitely do. They fucking abuse them, and maybe that's the reason. Maybe that's the reason is because they're allowed to be abused. This is my fear with generics. Hey, Mouse Potato, good to see you. Well, I don't mind exceptions. I wish they didn't exist. Return errors. Yeah, infection at first, but I absolutely love Go's error handling. Yeah. Thing that gets pushed to the end of the stack, and then you have a big debug and a whole bunch of stuff. Yeah. I actually wrote an entire exception error handling ability into Perl. I built it into my Perl class's pragma. It's beautiful. It gives you the full stack trace and everything. It's so awesome. And I still don't like them. Now, okay. So let's go on, see what we were working on here. So what are we doing? How many we got? We got 8 minutes left. We got our. See, the thing. This is when people start like. This is when people start reaching for libraries, right? Like, and then they start building their own utility class, right? And this kind of stuff. I mean, how many times have I written this? This is why I put this stuff in my command tab module, which I use for making utilities, like utility commands, and you get it for free. It's like stuff that you already need, but it's also kind of batteries included. But sometimes you don't want the batteries. It doesn't take me that long. But it did take me 25 minutes. Of course, I'm explaining it to y'all, but you know, if I had to write this every fucking time, this is a snippet. This is a snippet, and this is a snippet, right? So these, in fact, I probably should do that right now. I probably should do that right now. Yep, I'm going to do that right now. I'm going to make one. I'm going to make a snippet. I'm going to make a snippet. Where is it? I need to start making my own snippets library for this. So, because snippets are the next best thing to this kind of thing, right? Because then I could have just wrote it and just as a snippet, boom, it's done. It's kind of like your own AI, whatever, partner thingy mabob that people are raving about right now, right? It's kind of that thing. So what are we doing? So we got that. We got our exe. Back to our config. What are we trying to port here? We're trying to port this one right here. Just plain old directory. We just want an intelligent resolution of the directory is all. Cheaper than class instances. I think Rob mentioned this. Yeah. Python dictionaries are way cheaper than classes. Yeah, I actually did a lot of benchmarking with that. They're built on top of dictionaries, which is so crazy. So, yeah, it's not even low level. It's like high level. It's like a high level. Anyways, how expensive OP is? Oh yeah. Dude, Black Mouse, you haven't lived through true inheritance OP where they propagated the tree every time before tree shaking and mix-ins and all that stuff. Oh, so fucking bad. It was so bad. And it just gives me the chills thinking about it. I fucking hated that. I'm sorry, I'm swearing a lot tonight, but I warned you that these streams are going to be mature. Sorry, I'm not going to qualify for advertising or some shit, YouTube, because of that, but I don't care. I don't care. These videos will be at YouTube later. So all we did is we created two functions, one to return the directory, one to turn the file. We have an exe, but we don't actually need that one. Here's the thing. Do we really want to, this is a super big question, okay? Do we want to expose the current directory to the end? Yes, we do. We absolutely do. We want to allow people using this library to just get the directory and then do other things with it, right? So that's something we definitely, you never, ever want to overexpose things in your API that are not necessary for the end user. When in doubt, make it private because you have to permanently support that publicly exposed API function forever. And the pain in the ass that it is to deprecate something, just don't do it. Don't make it public. Because I was asking myself, should I make the exe, should I expose it? And I actually think I need to, because I don't want to force the people using this to have to do that. So people using this are going to want to look up the exe. Although I don't really need to, right? Because the conf.exe, no, I don't know. No, they can do their own thing. No, I'm not doing it. If anything, I have a question about whether I need to do that much magic. There's a lot of magic here that some of it might need to go. That you're not going to change it. Yeah. So Django is using average latency. Wow. Interesting. I'm just gonna look. I'm not gonna question the design. I'm just gonna implement it as is. We're gonna port it, and then we'll do some efficiency benchmarking and stuff like that. So we have everything necessary to make this. We just did everything to make that one line in Bash. Did I already mention to you about rapid applications development in Bash? It's taken me a full hour. I've been talking, but it's taken me a full hour to write the boilerplate code just to create this one line in Go. So we don't even have it yet. We need, okay, so dir, right? So now we have home and we have exe, right? And those are going to be blank. And we're going to join those with slashes. See, this is where things get really, really interesting, because I need to do some parameter checking. Otherwise, I'm going to end up like deleting all kinds of things, right? So over here, home is guaranteed to never be some dumb shit. It's just always going to be the right thing. AXE is always going to be something. It's always going to be something. But if I'm going to do it with proper error checking, I should not do anything with it if it's empty. So that means I have to check all those values. Yeah. I have to validate them. If I don't validate them, then kind of bypass, I'm writing code. There's a certain amount of trust that's going on. I don't know if I want to have that level of trust, because some might think that they're going to do this safely and like add a new file in there, and then they didn't have, for some reason, the operating system didn't have home defined, and all of a sudden they're writing stuff to root directory. You see what I'm saying? It's like, so this is the problem I have. So when I do something really fast and dirty in Bash, and I come over to Go, I'm like super strict. It's like, okay, somebody might actually use this in a way that I don't intend, so I'm gonna be more paranoid about how it gets used, and so I do shit like I'm about to do. So rather than just chain these all together, I could do this. I could say dir equals path.join, and I could say home, comma dot config. This is the literal exact translation of that line. That is the direct port of the line. What I'm trying to tell you is that because I'm writing in Go and I'm making it more enterprisey and safe and stuff, this makes me uncomfortable. Why? Why does this make me uncomfortable? It didn't make me uncomfortable over here. Well, maybe it doesn't make me uncomfortable because I do an existence check. No, I don't. There's no existence check. It's trusting that these like, what system has ever had home not defined, right? So strictly speaking, somebody could hijack this, and this is the hacker in me starts to come out, right? So the hacker in me is now starting to come out and go, well, what if this is empty? If this is empty, then it's just /.config. Yeah, for exceptions. What if this is empty? What if I can't detect, what if for whatever reason I can't detect the name of the executable? Now I just have /config/, and now they use that. Now they're trusting me. So where does that paranoia go? We should check that out. Config for existence. Yeah. Use my read. Lol. Yeah. So whether we should add it right here, I don't know whether we should put it or not. So should we check for the existence of this file? I mean, by the end of all of this, right? We probably should. So we should probably say, does it exist or not? And I mean, I should have written this code to be a little more robust. I should really write that code to be more robust. There's no doubt. And it's actually one of the reasons it's nice to port into a stricter language, even though it takes a long time, because you end up really thinking about the code and ways it could be hacked. But here's the question. Do I want to slow down everybody every time that they're going to do this? You know what I mean? So I actually do want to do that. So don't talk about drugs on my stream, and I'm banning you. Thank you. This is YouTube. This is going to be saved in YouTube. So if either home or exe is blank, I want to return blank to be consistent. Okay. And I can even put a little note to myself in the docs right here. This is not the final docs. So yeah, he really doesn't give a shit, does he? Yeah. Dumbass says what? P. All right. Thank you very much. I need some moderators. We're over time. I need to take a break, but let me just put a note here and say we'll return empty string if either home directory or current executable name cannot be determined. All right. So there we go. I'll return empty string if either home directory or current executable name cannot be determined. So I know I'm going to put other stuff in there, but I want to put that there because now I'm making a new contract, and this code is going to be way better because of it. It's going to be slightly slower, but it's going to do the check here, right? So then I do this. I say h equals, and by the way, one letter variable names within the scope. So this is a Go idiom. The smaller the scope, the smaller the name. So if it's not going to be used outside of a block within a function, it's usually a single letter. So home. So we say home equals home, and we could say, and then I mean this is going to be verbose, but this is the standard way to do this. You say if h, and if you don't like looking that up every time, you could maybe do it in an init session or something like that. So let's say this. So if h equals empty string, just return empty string, and that's nice and safe. This is very C-like. Yeah. So and then we'll get rid of that. All right. So then we say, actually, we can actually copy this into two. We can do E. We'll do X, I guess, and do AXE. And we could do or X equals, then just return it. So that's our nice, safe little thing. And then we can just join. Actually, we can do better than that now because the directory, we're going to return the directory at some point. So return dir. We're going to be doing other modifications on the dir later, but we're not ready for that yet. This is one of the things I hate is I actually have to fix this. H and then X, we'll put X here. Those will probably get inlined. Because these are such tiny little operations, they will probably get inlined. The Golang compiler is really intelligent about inlining stuff like that. So you might think it's incurring extra stuff that you'd have to check with C, but Go is really good at inlining that kind of stuff. Yeah, I could do that too. Yeah, absolutely. That's a great. Well, no. No, you know why we can't do that? Because it's going to reduce the scope. Yeah. So otherwise I would do it black mouse. I think it's a great idea. Yeah. Because if you, definitely we could do both of them. We could do both of them in there and we could put a comma operator between them. You could totally do it, but we just can't. The problem is it's going to isolate the scope and I need the variables later, So that's why they're up here. By the way, this is a Wallace operator. So it's exactly the same as this. It's exactly the same. If you want to put what type it is, you can. So the Wallace operator is something introduced in Go to kind of make it Python-y. That means it infers the type of the variable from the return value of the function. Super freaking cool. I love it. Yeah, I gotta take a break. Or X equals, doesn't matter. Yep, either one. I want it to break. Yeah. Yeah. If either one of these is that way, then yeah, we want to do. Okay, I'm gonna take another 5-minute break. Be right back. After the next break after this is gonna be a little longer because I'm gonna eat dinner and stuff. I'll still be here though. I'll be here till 8 o'clock. We still have quite a bit of time. We'll probably finish a good portion of this project. I actually don't mind talking through the project the way we have been. So I'll see you in a bit. All right, here we go. Here we go. Let's see. Yeah, take care, Fahrenheit. If you took off, good to see you. All right, so we've got our directory ported. We're making sure that we're being really safe, that we don't accidentally send back /config if the other two things are empty for any reason. And then, I mean, because it's time to be more paranoid, right? We're starting to write a real app here, a real application, whatever. And we have the directory file down here, which is calling this one, which is yet again the reason not to just call home, right? Because now we can reuse all this validation code down here by calling dir instead of all this. And we made sure to put a little documentation note so that that makes it into the final docs, even though I'm not writing all of the docs right now. I just want to make sure that that gets called out that way. Sometimes I'll do that to get my head around what the function is doing, and then I'll just expand that one-liner that, you know, is really succinct into, you know, user level kind of documentation later, rather than waste time writing docs. It's kind of a middle ground I've just hit over the years, you know, God, what is it, 6 years to go, or other embedded docs. Perl has it too, but I would always put it at the end, after the end, instead of trying to do inline pod documentation. Anybody remember that? Perl pod. And raise your hand if you know how to code documentation in Perl pod. Nobody's going to admit it. They will refuse. They're like, no, I'm not admitting that. That's like embarrassing. It is embarrassing, I admit. All right. So dir file, where are we? So what's next? Well, let's go back to our bash port. So we now have this. That's what we have. So the next thing is print. Yeah. Well, print debugging is still a thing. So xdg config home. So I have to spend a little time talking about this, and I'm going to set our Pomodoro timer. This is a really, really big one. If you are a Go programmer, please pay attention right now. There are so many Go programmers that don't know about this change. The change took place, I think, in 1.16, and it is now the standard way to deal with xdg home config. But so many people don't know about it, and they still keep growing their own, writing their own, and it's wrong. They're doing it wrong, and it's all been codified in the standard library. So I actually found this out by doing some research relatively recently. So what is xdg config home? The short explanation is it is the Open Desktop Foundation's standard for how to store things for users in any operating system, but primarily Linux and Unix. And that means, you know, it's also, the effort of it is to get away from, you know, a million cajillion dot files, and to organize those in a way similar to how the Unix operating system was initially designed through and you know, specified in POSIX as being, you know, /etc is going to be this, /var is this, you know, /user bin is this, /bin. They all have different meaning. And so the desktop movement has come forward and specified how users should be managing their directories and stuff. And many applications have got on board with doing that. They've decided to do that. So, and there's this set algorithm for dealing with configuration files. And the algorithm goes like this. If xdg underscore config home environment variable, which is long, I know, and it's the same on everything. It's the same on Windows, Mac, and whatever. If it is set, use that. That is the definitive full absolute path directory to the configuration file that contains subdirectories which are keyed off of the applications. And then there's no specification for this, but the applications generally should be matching the name of their executable. And in our tool that we're making, we are going to force that. So the configuration is automatically going to match whatever you're running as, and we're doing that on purpose. Because if you do a multi-call binary, or you change a copy, if you don't know what that multi-call binaries are, think about BusyBox, for example. You know, BusyBox has some 490 or so different commands that are all a single executable that's been copied, has actually been hard linked, and lots of other things have been, and the name is what gets resolved as the exe, and therefore you can key off the name. And it's a pretty common technique in Unix. It's pretty cool to do that. It's called a multi-call binary to do that. And so that's why we're going to stick with, if you want to, you know, use the actual name, we're going to, so that means if I make a binary, you know, called Zet, and I make another one called called ZP or something, then my configuration would be .config/z-config.zp or /zp. So the first thing we have to do is we have to see if they have this XDG home config variable, and you might go about the business of writing that little algorithm that I just mentioned. But here's the cool thing: the algorithm's already been written for you, and it was added to the standard library. And you can just go. It's Golang OS, and it's under the OS library. And let me see if I can find it. Yep. Wait. It's not shorthand for user. Yeah, everybody says user, but so we could go find. Let's go find it. GG. There it is. Okay, so here it is. os.user cache directory. Okay. And there's user config directory as well. So yeah, and this is where it talks about it. There's user cache directory. There it is, user home directory. Oh, wait. That's the one we're supposed to use. Oh my God. There's user config. This is it. This is the one that we're supposed to use. My user home directory is fucked up. That's the one. I knew it was there. I actually did a Zettelcast about this and I did it wrong. God. Current user's home directory, the end. Right? So I have broken code. My code busted. You know why? Because this utils.thing here is wrong. This is fucking wrong. Don't do that. Don't do that. I'm glad I encapsulated it. os.user home directory. And then we'll say H, and then actually if there's an error, it's just going to be yeah, I have to return it like this. I have to look it up, but otherwise it doesn't matter. And I can just return H. Let's see if we still pass our tests. Do we still pass the tests? Fail. Want values got. That's interesting. Oh, look what it did. Oh, it's because it's a config. Wait. Example dir file. Conf dir file values. What did I change? I did something wrong. Did I get the wrong one? I got the wrong one, right? Wait. No, this one's giving me the problem. This, you know why? This is a bug. Oh shit. This is a bug. It returns a map? Does it return a map? Oh, it does. Oh, it does. You're right. I'm sorry. I forgot about that. I forgot about that. No, it's a string. Home environment variable. On Windows, it returns user home returns home environment variable. Okay, I remember this now. I remember this. Now I'm having. I had a brain fart here. There was a debate about whether to use this or not because this will grab the home environment variable, which could be less secure. So if somebody changes the home environment variable, user home directory will return the new home directory environment variable. If the other one, the one that uses user home, will look from the Etsy password file or from the system, and it will always return the user's exact home directory file. So the question is whether we want the flexibility of them to be able to change the home environment variable and have it be notified. And I remember there's quite a bit of debate about that in the home directory one, and I think I ended up going with the more precise one. But I feel like this should be fine. So I want to test this. All right, so let's go. I mean, it's just a fucking home directory. remember when I told you, right? It's like all the extra little things you have to do. So I'm going to isolate the test to just home. And home already makes Rob pass. So that's passing. So home is passing. The exe one is not. So that's fine. I thought I broke something there. Yep. So yeah. That's fine. And yeah, I'm really glad we look this up. So we're gonna go to 5. So we came here because why? Because we wanted more than that, right? It got added at 1.12, which is a long time ago. That's good to know. We want configure. So configure, and see how it gives you all the rules about which one it's supposed to be. On plan 9, it's a different place. It's like, I just love it because it follows the conventions of the operating system. This is why Go fucking dominates, because it takes into account all of the operating systems that it supports, and it creates standard library routines that resolve the right things. That is a really big deal when you're writing enterprise software. So we're going to go back to, I don't even need to do the config thing. I can actually just add it direct now. I can get rid of this. Go back to here. I need to change that. That's confusing me. I just say template. All right. So, all right. And then we're going to do go dot, lib.go, right? So, all right, here we go. We got this. We're joining it. Will return empty string if either the home directory or the current executable name cannot be determined. The truth of the matter is, I didn't need to do any of that. Did I? Because that entire algorithm is covered for us. The home directory, this, and the config directory. Oh, no. This is a reading an environment variable that overrides everything else. And we have 2 different things going on here. Okay, so let's do this. So if process started, we'll have user and process name for sure. Yeah. It just cannot be empty. Yeah, but I don't need that because it will never be empty. I mean, let me take it back. Let's see. We probably need to. I'm gonna decide right now that I have to mess up this logic. I have to turn the logic upside down. So I have to change this logic right away because I want it. Okay, so this is not efficient. It might be easy to write, but it is not efficient. You want to return as fast as possible. So we're gonna take. This is something else when coding Go. In fact, if you look at the Go parser, it's a really, really good example of where they would change the most common success criteria and put them at the top of the function, because it's an optimization that you can do at this point. In Bash, is just get it out there and make it easy to write. The priority is on writing it quickly. Now the priority is on getting it to return as fast as possible. So my priorities have changed in terms of this logic. So I'm going to literally turn this logic upside down, and I'm going to say this. I'm going to say, first of all, we already separated out dir files. So if somebody has a file, we're calling something completely differently. We don't even care, right? And then what? And then we're saying this. So the very, very first thing that we need to check is there a conf-dir set? Because if there is, we're done. If there's a conf-dir set, we're done. So we do os.get env. Is it v env environ? I think it's env environ. Is it environment or env? I can't remember. So we're going to say get env config-dir, and we say say dir equals config-dir. It's get env, right? Yeah, thanks. I couldn't remember. And what? All right, and return. What am I missing here? 14. Oh, down here, right. What's up? Oh, quote. Thank you. Got my back there. So here we do this. We do get conf dir get return, okay, right? And then we say this. We say if dir has something. So if dir does not, this is kind of short circuit logic, right? It's a little bit faster. Say if the dir is empty, if it's not empty, then return it. Just return it. We're done. That is like super fast, right? If it's not, we're going to keep going. And since it's already defined, we don't do the while operator anymore, or declare, assign, whatever you want to call it. But now what? Now we say, all right, so let's use the xdg config home, and both of these lines of logic are already covered for us in that one thing. So we say dir equals fact. In fact, as far as we're concerned, that is the only option. So because it's the only option, we can actually return it directly. Well, I think no, because it's got two variables. Yeah, we already know. Oh, we can just do this. Return. What do we say? No, we can do it. No, that was home directory. That's right. Never mind. So we can do dir, and this actually is a little bit weird because when you have two return values, you got to watch out whether you do this. You can get really bit by that, by the way. There's a lot of really subtle bugs there. If you don't lint it, you won't find them. And we're going to do os dot user config dir. Is user config dir or config home? I think it's config home. No, it's user config dir. Okay. So, and now we just return dir. Now, if dir is empty, sucks to be you, right? That's a problem with your system, but we've done our best in power. And that actually saved us a lot of coding. So let's go test that and see what happened. So we should have, what should we have here? We should have example dir should actually be /.config. And that's, now I'm gonna cheat here. No, it won't work. It won't work. We can't emulate it. We'd have to add a layer of abstraction just to emulate it to be able to test it. I'm not gonna do that. So yeah. Sometimes what you can do is you can add an environment variable or two, or add a package variable, and you can set it in your tests and say, okay, use me from now on. I'm the user. And it'll do that. So in this particular case, we can actually cheat because we know how to do it. You know, we actually can do this. We can do os set env. Oh my god. This is gonna work now because we're using the different one. So yeah. Example got config values, want values. No, that's not my, what? Oh, wait. I need if you're going to do this, you got to trail it. There we go. Dot config. Pass. All right. So you see what I did there? because os.userHomeDir respects the environment variable, you can set the environment variable in your test to make your test work. So we can use that little question about whether we want to do it or not. We can actually use it as a hack to make our test work. So that works. I mean, that's it. That's really all there is to it. That's it. And then what? So, no. We want to add the exe onto the end of this. Yeah, I forgot about that. We want to add the exe onto the end. So we want to have slash and then the name of the file. This is going to be weird. It's going to be conf dash. It's going to work though. I'm kind of happy about this because that's the executable. You see what I'm saying? I'm happy about this. So yeah, because look, we forgot about that. We can't just return the dir. We got to join it with the exe, right? I mean, if there's no exe, we're just going to return nothing. That's another thing we have to do. So I'm going to say x equals exe, and if x return, I can be really sloppy because of my editor. My editor will take care of me. So I can do this and oops. And so then I can just do this. I can just return join dot dir ex, and what? Oh, path.join. I think it's path.join, right? Yep. All right. So then what? Down here we have another one. Join. I mean, it seems redundant, but whatever. And hey, look, we passed. So that's fixed. That's test-driven development right there. Getting your stuff to pass and, expected outcomes and document at the same time. Huzzah! If you use the third function, ext path, you kind of need that, right? We kind of do need it, don't we? I mean, that's, you know what, Black Mouse, I think you're absolutely right. I mean, no, well, I think you might be right, though, because sometimes you might want to get to the base directory, right? I think you're right. I'm glad I listened to you. Yeah, I like it. I like it a lot. I like it. I like it. Func dir exe conf.dir exe, yes. And this actually would be exe file. Yeah, I like it. Dir exe. It's kind of like, you know what I mean. Much better. This is much more usable. This isn't Bash anymore. exe path for combining everything. Conf.exe path. Exe path. Conf.exe path. Conf.dir exe file. Conf.exe file. Conf.exe path. No, because they're going to think it's executable, no? Conf.directory. I feel like we're losing our dir in there. Conf.dir. This is the base conf.dir configuration directory. You see what I'm saying? Let's see. Conf path. Conf.exe path. We could probably get away with this. I kind of want him to build. I like conf path too. But we already have conf. See, conf is already in the package name. So it's going to be conf dot. You see what I'm saying? So instead of having dir, we should make that probably path. So conf.path, that is the path to, we could have conf.exe path. How about that? How's that sound? I see what you're saying though. Conf.exe path. I like path because it's like it implies it's the whole thing, right? Conf.path, conf.exe path. We'll fix everything else. And then conf.exe file path. I mean, I don't know. What do you think? You like that? Conf.exe file path. I don't want him to think that's an executable file, though. You know what I mean? I know. Let's do conf exe path file. How about that? Package path. No, hell no. No. I would never do that. I don't like sub packages. So it would be, because I want to be able to import it. so conf.path is fine. Conf.exe path. Conf.path is just a generic path to the configuration directory, which is taken over by config directory or whatever. This makes me wonder if I want to use config_dir or not. I feel like I do, though. At one point I had conf-dir like that, but I don't know. What do you think? Call it path? exe. We already have path. Are you saying you don't? Okay, there's one. Okay, so this, we're not gonna have a join in here anymore. That's what I'm talking about. So conf.home. Let's do that. That's what I'm doing. I'm putting my foot down. All right, this whole thing's gonna have to change, but I see what you're saying. So second system syndrome. So conf.home is yeah, it's conf.home. So conf.home is like, this is your home directory. This is where all your configurations are. And that's gonna be, yep, I got code in here that's gonna be messed up now. Yeah, this is gonna yell at me, but I don't care. So let me figure out where it's gonna go. So conf.exe is gonna be, exe is gonna be the path. So this will be the path, conf.exe. And but we do need home. Conf.home. And conf.home is this stuff. So home, yep, that stuff's all going to go away. But that gets rid of that redundancy, which makes me very happy. You know what I'm talking about? Yeah. Yeah. This is good. This is much better. I don't. Config. I'm going to call it config. I don't know. Should I put this underscore there or not? Oh, I got to go eat. I mean, this is why it takes so long to code go, because, you know, we're fixing stuff. So path join. And then we're going to grab the home directory. So we say, how about this? If x equals home, h home, and it's different than the private one. You can do that, by the way. Or h equals return that, otherwise return a join of the directory, the home directory, and the executable. Dir and exe. Or return empty string if either home directory or current executable cannot be determined. I mean, you could just send it this. I could say exe returns a full path absolute path to the path to a subdirectory of the configuration home, right? Home config directory named after the current executable binary. Or return an empty string if the home directory or current executable name cannot be determined. There we go. Sometimes I do this, make it readable. And well, we've got home. This is all good. We need to test all this stuff now. Home returns the value of config environment variable if set or the os.user config. That's it. That's all we need. And so those two are there. Conf.home, conf.exe, and then this is file. So conf.file, we should probably say exe file. Yeah, I think exe file. This one needs to go up. This one needs to go up here. All right, exe and exe file. Exe file returns the specified file. Returns an absolute path to the specified file within the exe directory. And you know, they should pop up next to each other. All right, let's see what else we got here. We need to test all that. So when I come back, I'm going to test all that. This renovation of this has really proven valuable because it's going to be a lot better. When I come back, I'm going to test this. I'm going to take a bigger break. I'm going to be gone for maybe 20 minutes because I have to eat, and then I'll come back. And then, so if you're watching YouTube, just pause or whatever. Do I look orange to you? I'm looking at my camera and it looks a lot more orange than usual, and I'm wondering if it's because I got suntan or something. A bit. So during this break, I'm gonna take a 20-minute break. Yeah, I feel a lot more orange for some reason. I'm just gonna fix it really quick. I can't stand it. I feel like really, really orange. I think we need to go do this a little bit more. Tell me when I look normal. Bronze. Yeah, fuck no. I think I'm gonna go back to normal temperature. I mean, that seems better. So that's a little bit better, right? I don't know, can you tell? So I actually haven't set that, so we'll go ahead and yeah, I'm not as orange now. I am sunburned, so right here, that's the sunburn. Is that better? Okay. I'm definitely red because I've been in the sun. I got sunburned, so I'm just checking my skin tone here and my guns. I gotta go. I'm gonna take a break. Thanks for hanging with me though so far. We'll be back. We're gonna be here until at least 8 o'clock. Maybe a little over that. We'll see. All right. So go take a break. 20 minutes. Okay, let's go. All right. Oh, good food. If you guys got a good break, we'll go to 8ish. I'll just wrap this up. Probably 8:20. We'll see how it goes. I actually am going to start doing this more. So this is stuff I need to do anyway. Might as well do it. I'm gonna give it a try to the lights with the hat and see if that attracts more people who want to learn how to code, etc. So let's go ahead and go for it. So right now, where are we? We've got, again, our goal is support this template script, this config directory function, which actually at this point I believe we've got finished. What we want to do is equivalent, of this is return the XDG config directory automatically. So we need to write our test code for this now. We just completed this code, and I'm going to go to the example test code here. I'm going to reset all these names so that they're right. So we have conf.home. So that needs to give us the home directory. So let's fix that one. Let's get all of our tests running again. Undefined dir fail, lib line 37. We got a problem here. All right, exe file. So we're going to join the exe. That should trap that one. Conf.go tests, undefined conf.dir file in our examples. So where's our dir file? Let's get rid of that. So this will be exe file. Oops, so change that. And that should change that one. That's running. Got conf want argx values exe file. Okay, so well, we're going to cheat on this one too. Set the home environment variable. And interesting, that does not change. That's interesting. No, it does. It does change it. It does change it. No, that's what we want actually. So I'm going to check this one down here and change this to /values. That should pass. And what else do we have? I need to drop the -v. It's getting in the way. So we have another one failing. Let's see. Conf. What is that test for? I can't see it because it's hidden. You know what? Oh, it is home. Okay, so up config. No, this is not what we want. We want config because it's just a home config. Yep, config to home. Yay, pass. So we have home, we have dir file, but we probably don't have very good coverage. Let's try our coverage. So how is coverage we done? We're going to do, I actually have a coverage program called GOC. It does all of it for me. You can go look at it if you want. It's in my .dot files. It converts the coverage output into HTML that can be read with links and has color highlighting. And so then it tells me exactly what parts I'm missing that aren't getting tested. This is virtually impossible to test. It's just because it's dependent on the system calls, so I'm gonna have to leave that out. There's no way I can test that. So yeah, so 86% coverage. So that's pretty good so far. Coverage is, as always, a bad measure. I don't recommend people primarily depend on that, but we don't have all of our examples, and we have exe and non-exe file. So I do want to put that in here. So we're going to put that into the test. Utils test, we need an exe and an exe file. So we'll put that one here. Exe file. Oh, wait. You know what? I'm kind of starting to think, okay, so that was home. I don't even need that. I mean, we really don't. We don't need that. I don't think we need it. I don't. Nope. Yeah, we didn't even use it. We didn't even call it. So everything else uses off to this, so we're done. Yay, we got rid of some code we didn't need. exe is the base executable. Conf.exe. I don't think we need that either. I don't. I mean, that's simple enough that we can drop it. Goodbye, utils. I am not afraid of removing code if it's going to make things simpler. Okay. X. Yep. Absolute path. Huh. I have to do this. I'm trying to think of a better way, but I don't want to do it there. Absolute path, base path. I mean, if it's empty, it's going to be the base of empty, and it's going to be still empty, so we can leave it. Okay. I had to just think about that for a sec. Oh boy. Now I've got problems because I have this thing open. Yeah, that's fine. All right, so home exe path, and we're still passing all our tests, and we got rid of the useless util thing. We're good. Our examples are all good. We are missing an example though. We're still missing one example. So we're missing we're missing a file, I think. Home a file, no, exe. All right. So func example has to be called example again. File, and then we need to output something. So output, and what will this be? Let's say, wait, oh, we already have that. Example exe. Well, we already know what this is going to be. We know this because I mean, this is a stupid easy test. We just replicate the previous one, and then just add the values file, or the name of the executable, which we now know because it gave it up. conf-go.test. So that should pass. Yeah, this is not home. This is now exe. Conf exe. Yep. All right. So we have that is a committable moment, in my opinion. So we're not done, but I feel like, how am I doing the tests? I'm just running go test in a loop. Actually, it's not a loop. It detects whether there's any changes to the files, and then it makes a test. So it's go test like that. That's all. That's all it is. Go test -v. It's just in a loop, and it detects changes to the files. So those also become, the examples become a part of the documentation. That's why I did it that way. That is a committable moment in my mind. Commit often, commit early, commit often, they say. So status. I mean, I'm going to commit it, but I'm not going to push it. If I push it, I'm going to break shit. So I'm not ready to do that yet, but I can go ahead and commit it. So I have a backup. If I screw something up, I can go back to that moment. So commit, What do we do? What do we add? Git diff. I don't know how to do incremental or itemized diffs. They're really cool. I don't know how to do them. There's actually nothing there. It's all new code. So we could say that we added home exe and exe file. No, we don't need to parse that. That's all being taken care of by the library. So go wait, git commit commit dash a dot what? That doesn't make sense. Is it not a git file? That's weird. Examples, go lib. It's kind of a weird commit, but oh well. Commit, add initial, let's see, add new base with home dir exe file. All right, so yeah, we're kind of ahead because I'm making changes to the original one that was all JSON. So let's go back to our bash and have a look. This is done. That is ported. So what do we need besides dir? Well, we had path. Okay, so path was giving you the path to a specific file. We have that now. We have that called exe file, so it doesn't need to be called the same thing. Yeah, and then what else we need to do? Keys and values. Okay, we need to do some parsing here. We probably should do the parsing next. We're not going to delete anything. We have to actually load the file, and that's going to be the most of the work. And I think we can get a big part of that work done tonight. We need to be able to get to the file and everything. So I feel like that's all covered. And now we need to kind of make the file. So what is that call going to be? That's going to be, well, it just runs when it starts. So I gotta remember how that works. Excuse me. I think it's an initialize. Nope, it's not. Huh, where'd I put it? Where'd I put it? Config read. That's it. We need read. That's what we need. Read is really important because that gets a fresh read and locks the file and stuff. Speaking of locking, I don't think we're going to be doing any locking because it's, first of all, file system locking is really impossible to do, and you're not always on a system that's got a consistent file lock. And if everything doesn't use the same method, it fails. And you end up leaving files around, and you have to remove them, otherwise it's just locked. So we're just going to depend on file system locking and coordination. We're not going to put any of that in here. I'm going to put a big disclaimer in here on that because that's super important. Everybody wants to do their own. Everyone wants to do their own locking and file, atomic file access and stuff. And I don't want to get into the business of doing that because I don't know. It just doesn't feel like. I mean, there's lots of ways that it is attempted, and they're never ever good enough, and people don't know that. So what am I thinking about here? So we're about to make a read function. So the read function, rewriting the file, is the very essence of why databases are created. So databases are created because they can ensure atomic access to a bit of data, and that nobody else is going to fight for it. There's not going to be any contention or anything. When it comes to accessing a file from anything in the Unix file system, Unix or Linux or ext2, whatever, 3, 4, 5, whatever version, Btrfs, this is constantly an issue because there's no such thing as atomic read writes. Now, from what I understand with Windows, there is no such thing as a non-atomic read and write to a file. It's actually handled by the operating system. I don't know that for sure. I've heard that. But when it comes to Unix and Linux, you can concurrently read all you want on a file, and that's fine, right? But when you go to write to a file, it gets problematic. Because how can you guarantee that somebody else is going to write to the file? And I haven't checked in on this. I did like a week's worth of research at least, like several years ago, more than a decade ago, actually. And actually, Randall Schwartz has a good write-up on this. It's Pearl God from the 90s, but about the problem. Because the assumption is that writing, even in append mode, to a file is safe. And it's absolutely not safe. If you write to the end of a file and somebody else is writing, you can both write to the end of the file, and that's totally allowed by Unix and Linux. Yeah. So Windows, Linux and Unix can write to the end of a file, no problem, right? But that doesn't guarantee that each line is going to be written. Now, from what I understand, almost every Linux distribution is designed to flush a buffer on line return. So, you know, every system's got different configurations for when it gets this buffer flush. If you've been doing encoding for any amount of time, you've been burned by, you've done Piper buffer overflow. In fact, let me show you. It's like the world's shittiest variable, environment variable. So if you've been doing Python coding, you already know this. Don't write bytecode. Actually, that's a different thing. There's, I was thinking about the other one. I don't have it in here. Damn. There's a setting you can set on Python and Perl and Bash that will force flushes of standard output as soon as they happen, and it's really slow. So file I/O is, you know, the big bottleneck that everybody forgets about when they try to compare CPU performance between two things. It really always is going to come down to I/O weight, and so why does this matter? Because so for buffer over, this is all just a simple script, right? But this is all. I have to tell you all this. I have to rubber duck all of this because we're about to make a very important decision. Do we make our code safe for writing to the file, and under what scope? And if we're going to do that, we have to buy off on a lot of assumptions, right? We have to buy off on a lot of assumptions, and some of those assumptions are just plain false. And most people doing an application like this wouldn't even think about this. And that's not a flex. I honestly, they wouldn't even think about it. They would just do it and then be done with it and they would go. And that's exactly what I did when I wrote the Bash version, because it's rapidly applications development, right? But now we're trying to build a library that's sustainable and enterprise worthy and stuff. And so we need to think about concurrency, concurrent write access to files, blah, blah, blah. And then you just have to start asking questions like, well, how is Go going to behave on a different operating system? We have this whole cross-platform compatibility thing about Go, right? Well, if it's on Windows, we already know it's not a problem, right? Because you cannot write to a file in Windows, according to what I understand, and Go can't do some magic and allow that to get past the system constraints. It has to, every single file has to be written to an atomic. Everything that writes to a file is an atomic write. So, and from what I remember, you can't even read unless you have just one thing to read at a time, whatever. So here's the normal way that a sort of pseudo-aware programmer would do this, and it's broken every time. And this is why I'm struggling, because, and Randall actually writes a really great blog at length about this. That's the first time I read about it back in the day. Because I was writing a ton of Perl, and I had all kinds of processes that were going on that had to collaborate and decide when it was going to be safe to write to a particular file. You know, it's like I have like half dozen agents all running on the same system, and they're all looking for the same directory, and you got to prevent, file contention, erase conditions, and stuff like that are not the kind. When I say race condition, people immediately jump to coding erase conditions. No, this is system level race condition, where you have file contention and things like that. And you don't think about these things until you start working at the enterprise level and enterprise scale. When you're like, really, there's a lot of stuff that's going down at the same time, and you're like, because you're never bitten by it. You could write it in Python or Bash or anything. You never, ever, ever have a problem with it. But as soon as somebody decides to use your library in something that's doing, 100,000 configuration writes per second or some shit, which it shouldn't be doing anyway, because there's other performance, problems with this particular properties configuration file that we're using. Bottom line, if you're going to do that kind of thing, use a fucking database. That's what they're for. Even if it's SQLite, use that, right? Because SQLite has built into it, these kind of concurrency checks and locks and everything. So one of the common techniques for doing this, for protecting yourself from concurrent writes, at least from everybody who's using your same library, right? You can never stop somebody else from writing to the file, period. They can have the file open in VI, and you can have some other application that goes to write to it, and it's going to say, the VI is going to go, somebody wrote to this file, like, what? And, it'll like load the file changes, right? So because you cannot, just because you're writing a library doesn't mean you have full, you're not the king of the kingdom for that whole thing. You can't prove that everybody's not going to follow everything. But you can at least say this. You can say anybody, any program, anything that's using conf-go will be safe for concurrent writes to this directory. All right. And that is an agreement that you can then codify within it. And then everybody just agrees to use that in the framework, and you're all good to go as long as you're all in the same version of the framework. And then if you want to, you go an extra level and you can say, okay, we've got, this is how we're doing this in our code. So if you want to write it in Rust or JavaScript or whatever, just observe this thing that we do to make it so that you can check whether you can write or not. And 9 times out of 10, what that will be is some sort of .lock file. And what that'll mean is that there will be a file that gets created. Now this is really easy. This is really easy to confuse, because people will think that this is probably the most confusing thing ever when it comes to locking. Beginners, they'll see a lock file. They'll see a .lock file, right? And they'll go, oh, if this file exists, it means this whole thing is locked. That's usually not what it is. And this is usually, okay, so there's a system call called flock, and we're going to read about it. Flock manages locks from shell scripts. All right, so this actually has an underlying syscall and everything. And so the normal way to do this is, you can do this from a shell script or from Perl or from Go or whatever. Is the normal way to do this is to create or to maintain a log file, and usually it's in var run, by the way. So var run, right? Var run, do they have lock? Okay. So this is what normally will happen in this kind of situation. You'll have people, they'll create var run log files, right? And the idea is, and I love that they have var run lockdown. They didn't have it in the 90s. It wasn't a thing. And I don't even know if you can make one. Let me check. Can I make one? I can. Good. These files, of course, are cleared out on reboot and stuff like that. In fact, I think it's an ephemeral file system. Yeah. Wait. What do I want? DF? Yeah. See? Tempfs. So it's a tempfs. That means it goes away if you reboot. Something interesting I noticed not too long ago was that I don't know when they did it, but /temp is no longer ephemeral. It's not a tempfs anymore. There's a script that clears it out, but it's an actual part of /. So it's no longer a tempfs. That's a pretty big deal. To me, that was a big deal when I noticed that. For Docker is overlay. Is it really? Nice. Yes. Oh, that's right, because you have to go in there. I was playing with that on the node the other day, actually. Now that I remember it. So what is the normal Unixy thing to do here? And the normal Unixy thing to do here is to create an entry, if it doesn't exist, in var run whatever, some unique identifier for your application, and pray that nobody else has the same name as you. There's just really another way to know. And I mean, you can't really build in the process ID or anything like that, because you need to be able to consistently open the thing. And then everybody that's using your code agrees to lock that lock file. And yet it doesn't make sense to you at first, but I have to make sure you understand this. So just creating the file. So this, I don't know if this is a Windows misconception, because of course, if you can't even create a file unless you have a lock, right? Because it's built into the Windows system. But in Linux, you can build a file and access the file as many times as you want. That's fine. You can write to it, and there's nothing being blocked at all. And it's really cool. That's why you can have so many people tail and write to the same log file and stuff. That's why you can get log files that are corrupt, because they don't wait for the line to finish before the next write comes in. You get all kinds of problems with that unless you do some kind of concurrency. I mean, they've done enough things, because so many people don't think about this. They've done enough things these days that it almost never happens that if 3 or 4 or 10 or 100 processes write into the same file, that you actually get corruption in the file. They're all, as long as you write per line, everybody's going to flush their line at the same time. It's usually always a line flush. But if somebody flushes ahead of that, I know it sounds weird, but if they do, there's a chance that they're going to only write partial line, and then you're going to get a log line that's going to be corrupt. So the way to do that is to actually use a lock file. And then what you do is you create the lock file, and then you take a system level lock on the file. And that is guaranteed to be atomic. And that's how databases do their thing. So you take a system level lock on that thing, and nothing else on the system that goes to take a lockout on the same file, it'll block. So it's a semaphore. And if you know about concurrency and setting up locks and semaphores and mutex, it's a mutex. That's what it is. If you know how to set up, if you know about concurrent programming and all that stuff, you probably know a little bit about mutexes and mutexes or whatever, I don't know. And you know what a semaphore is a little bit different, right? Semaphore is, by the way, it's the same word that's used to tell traffic which direction to go. It's like go left, to go right. That's a semaphore. It tells you which direction to go, and it's atomic. It's guaranteed to always be one or the other direction. And a mutex is like, okay, it's this atomic thing where if you lock the mutex, nobody else can do it. They have to get locks on it. You can have different policies, and there's like read-write locks that allow people to read. But if you take a full, read and write lock, it'll block all reads as well. So these things are super important when you're getting into concurrent development. And this is usually the time when somebody from Rust world would like chime in and say, oh, Rust doesn't have a problem with concurrency. It absolutely fucking does have problems with concurrency. Rust is not going to save you from file system level locking that we just talked about, because that's an operating system thing. In that sense, Rust is just another language and has the same exact problems. So no amount of concurrent safety or whatever the fuck is going to save you from these concurrency issues in the system. And this is one of the main reasons that I'm so critical of Rust people immediately spewing how awesome the language is going to take away all your problems without considering the larger picture. Because the larger picture is more about doing concurrent I/O, not doing concurrent memory access and concurrent CPU access, stuff like that. The more problematic issue is always going to be concurrent access to the file system and to input and output and resources like that. And so we're about to hit this issue because we have to make a decision. We have to make a very simple decision. Do I lock before I write? That's it. We have to answer one question. In my bash script, I'm not doing that. In my bash script, I'm not doing it. I'm trusting that no one else is ever going to try to do this thing at the same time, because I know that my system's pretty limited. I have a bash script. I don't have anything using it, but I'm trying to make a library here that I could use for anything, right? And so I don't want that. This bash template's all well and good to a degree. The really crazy thing about this is if we do this right, that bash template script that I have, I could add an flock in there, and it could observe the same concurrency locks and mutexes that are observed by Go or Rust or anybody else. So if we do this right, we will add concurrency safety, concurrent write safety to everything. And if we're on Linux, we can implement it in Bash. We wouldn't be putting Bash on Windows. It would be Linux, right? But so we have to do a little bit of research here. And this is where, it's just a Bash script. No, it's not. If you're going to take it to the next level, but this is another reason, by the way, to reach for a language like Go. I bet you $10 that we're going to we're going to dive into Go, concurrent file access, and we're going to find some user space, some userland utilities that take care of all this shit for us, so we don't have to do anything. But the way it takes care of it most probably is going to be by setting up something in var lock. And if it is, we can glean what that method is and reuse that same method and make our bash script even better, because now it's observing the same lock, and then we never have to be afraid of somebody changing a configuration variable and someone else changing it at the exact same moment and having them overwrite each other. Chances of that happening is like 0.0001% in my world, but we're making a library. And when you make a library, that's a different story. As soon as you start making a library, you need to be more aware of the possibility that people are going to push your library to that extent. And then when it breaks, you're going to say, we're not supposed to do that. And I'm like, well, we did do it. And you'll be in the same boat that, every other software development team gets in. People push their libraries and stuff past the boundaries of how they were designed to be used. And then you also have that combined with the fact that the people that created the libraries in the first place didn't disclaim all these issues with concurrency and stuff. And then what? Then hackers make tons of money. Because you can create a race condition, you can force the configuration file to be corrupted or have some other thing written to it. And now someone's not just doing their little Zettelkasten configuration, it's configuring some $1 million software application. I'm just saying, you think it doesn't happen, it actually does. People take these little hacks that work really well, but you know what? This happens all the fucking time? Nodeland. Nodeland is full of like script kiddie shit running on billion-dollar enterprises with finance applications, because there's so many fucking NPM modules that have been pulled together. Not any of them have any quality control at all, and it's no surprise. And by the way, they're not even checksummed, so they're committed by all who knows whoever. Nothing's signed, at least it wasn't. And boom, somebody breaks in a Lodash, and the whole fucking thing falls apart, and we get the biggest internet worm in history because of this. So you might think I'm being pedantic and I'm like I'm splitting hairs here about all this shit, but more people need to do this shit, because if you don't, I know, because remember I said code like a hacker? You should be writing code with the intent to break that code. Like, how would I break this? And if you're not doing it that way, you're doing it wrong. I'm sorry, you're doing it wrong, and you're causing people to die, literally. Because people are hacking systems and they're ransomwaring the shit out of hospitals, and people were dying because of it. So if you are not being a pedantic asshole about whether you should get right concurrency access, you could be causing someone to die. I don't know why I went there. I just did. But it's true. It's true. So, care about stuff. So how are we going to do it? Well, I know how I could do it right off the bat by just writing it all out. You can write it all out, and we can do it in Shell, we can do it in Perl and Rust or whatever language Go. All we really need to do is create a var run lock, and we just need to get a file lock on that lock, and we need to do a syscall. The problem with doing that, though, is if we actually do a Unix syscall, we've then crossed over and started to use something. If you don't know Go, I'm going to show you this. So this is in my bash RC. I have this here on purpose because, see this? This is environment variable. You definitely want to add. Somebody told me about this probably 6 months ago on the stream, and I knew about cgo, but I didn't know you could just put this in your environment and save yourself. You put cgo enable equals 0, and that means your code in Go will not compile if it requires cgo. And that's a long story about what cgo is. The short version is Go is 100% compatible with C. You can literally write C code and do import C, capital C, and it will run it. You can mix Go and C code together. It's really fucking amazing. I mean, when you see it, you just will not believe it. You can't tell whether it's C code or Go code because it's both. It's super amazing. If you can literally write Go files that have nothing but C in them. But to do that, you have to use cgo. And as soon as you use cgo, you've blown your cross-compile possibilities. And if you don't know what that is, that means that Go's one of the biggest claim to fame is that you can compile on a Mac a binary that will only run on a Windows machine. and ARM, et cetera, et cetera, et cetera. It's called cross-compilation, and it's really amazing. If you've grown up in any kind of situation where, I actually maintained build labs for Tivoli and Rational while I was at IBM, where they had to have one of every type of operating system they were going to build on, because they had to go to that computer, they couldn't even network it, and they had to build the software every single time for every single operating system on an operating system that was running that level of binary software. This is pre-virtual machines and everything. So, and these days you can do it with a virtual machine. Seago is not as bad because of containers. So once again, developer build containers. People talk developers all the time. Why do I give a shit about containers? Well, this is yet another reason you should, because now you can actually bring up a container, or a virtual machine, either one, and then you can build according to that architecture. Now, actually, strictly speaking, that doesn't work with a container. That doesn't work with a container. I take it all back. That works with containers as long as you're just testing out different libraries and stuff. But because it's being compiled for that emulator, you'd have to use something like QEMU, or you'd have to use a virtual machine for that, because the virtual machines can actually change the chipset, and containers can't. Containers are all locked down. I kind of misspoke there. But Seago. So what does Seago do? Seago says, occasionally when you're looking through the standard library and you're picking and choosing what you're going to use, and we're about to do that, you're going to pick something that doesn't work without Seago. And you'd be surprised. So any of basic syscalls, so like exec, right? So let me give you an example, one that's really common that I love. So if you want to create, it's very efficient. The other thing about Seago is it's like a give and take, right? If you activate Seago and you start to use some of the C syscalls, you can bypass all the emulation layers in between that Go has to go through. Go's really efficient at doing this, but if you're calling it, if you use Seago, you can call system calls directly. That means you don't have to have indirection, like 1, 2, or 3 levels of indirection before. It's so fast, you'd never notice it. But when you're talking about scale, it's a different thing. So basic thing, I just want to run a program, right? From Go. I want to do an exec, like I would do, from Go. From Bash or something. So there's an os-exec. And this is just a good example of where you have this. Package runs external Go commands. So this is OS exec, right? So everything in OS is meant to be 100% cross-compatible across all operating systems. So anything in OS is safe, including user home config. I don't know if you saw, but that user home config thing we just did, or user config home or whatever. But there's a bunch of stuff that's not safe. And I will show you now. It's stuff under sys. So yeah. To comment that you can specifically run QEMU-based Docker containers. Can you really? Well, what I want to know is, can you compile for ARM in a container? And I don't think you can. I don't think you can. I think you might be able to do that, but I'm just wondering if somebody wanted to cross compile and they wanted to cross compile for ARM from a Linux machine, can they do it? Do you do it really? Actually, I think Jenny says that she does too. I think she does too, but that's because it's using emulation, right? It's using emulation. It's not a hypervisor. We talked about that last Friday during our Kubernetes time, and we're going to talk about that again this Friday again. So XSys, so sys, Go packages for low-level interaction with the system. So if you're using anything from the sys package, and believe me, there's some pretty cool-ass shit in here. This is good shit. This is like direct access to the syscalls. And I'm trying to find the docs for it. No, I know it's there. Golang, sysdev, nope. Arch Linux, nope. Wait. It's really fucking cool. The reason I love it is because you can do low-level systems programming in Go. This is why people wrote low-level things for the OS in K3OS, which really took me aback a bit, because they were using Go for low-level, like kernel-level development. And not kernel-ish. It wasn't actual kernel development. Don't hold me to it. But it was pretty damn close. That looks like it's just the runtime internal sys. Yeah, there we go. Oh, that's different. That's not the same. Did they change it to be runtime internal? They did. Wow, the path is all fucked up now. It used to just be ./sys. They've totally changed the path. It's why Go is used for Docker. Yeah. So I feel like they moved it though. I don't remember it being a runtime internal. I thought it was just X. It was XSys and it was just sys for a while. It looks like they moved it. Looks like they moved it to runtime internal. That's interesting. So wait. No, that's 1.71. So it's the latest. Okay. So here we go. Lens 64, trailing zeros. This is where you have a lot of the unsafe stuff. You know, God, look at that. The big Indian thing. I mean, these are all considerations for, yeah, see this like sys.go arch? This is a constant. I love this. You can use sys.go arch and whatever, and you can look up what the architecture is in your code. So you can actually write system specific code that that branches like that. Normally the people don't do that. There's a build mechanism that allows you to put the architecture in the file name, and only the files that contain your architecture name will be included. There's also a go build directive that allows you to do that. So I'm kind of getting ahead of myself, but so yeah, this is super cool. But you can add, look at this, see pointer sizes and stuff. You can do, it actually requires a larger stack for syscalls. I mean, this is stuff that you would normally be reading about in C. Added in Go 1.7. Capture the level zeros. I mean, and it's not just this, right? It's also syscalls. So yeah, I don't see any here though. I don't know if that's the one. Wait. And then sysrep said this is. There is a standard sys package, so. There's a sys exec and what is it? A sys exec, and that will do the exact syscall that you want. That's the same thing you do from the command line in Linux. Did you find it? Yeah, I don't know. I want to say it wasn't under X before too. I don't. Yeah. This says get UID. Is that the one? It is XSys then, huh? Okay. All right. Thanks. So I didn't know which one. There's more than one sys in there. Sys Unix. Sys Windows. Yeah, here we go. So download, install. Wait. No, that's not it. Where's the package documentation? There it is. That's it. Golang sys, no? Where? I'm not finding it. I could probably just do the package stuff. Yeah, but that's not the docs, is it? Yeah, that's the source code. That's the source code, I'm pretty sure. I'm looking for the package docs. So, here, let me think. So, like, if I was going to look up time date. Yeah, golang.org, package time. I'm going to do that. PKG sys. Is that a thing? Oh, look, it redirected to runtime internal sys. It went to runtime internal sys. Did you see this? Yeah. That's interesting. So it's x/sys. Yeah. So packages x/sys. There we go. Nope. That's interesting. That's really interesting. No, because it's not a package. Redirected to documentation. Yes. unchecked, checked. Sys, this project holds supplemental Go package for low level. The operating system, the system is the easiest way to go get. It is X. Okay, so it's X/sys, not runtime. All right, before it uses, yeah, CPU. Okay, here we go. Yeah, yeah, this is all the top level packages. I don't, did they reorganize it? Please tell me they didn't. Because I don't see, I don't believe it was under Unix. I want to say it wasn't. Yeah. Functions. Oh, here we go. Wow, there can't be one sys package. I know it's if I can find the exec, I'll be able to show you what I'm talking about. So there's an os.exec and there's a sys.exec or a unix.exec or whatever it is. There definitely is. So this is shmode and shown and all that stuff. Yeah, this is the one we're looking at. I think they move stuff around. I want to say they move stuff around. I don't remember it being Unix like that. I don't remember that. I think they did. I can't remember. But it feels to me environ Unix exec. Yeah, it is Unix.exec, right? All right. Well, I want to say that that's changed. I don't believe that from before. Hello.
Were you ending at 8?
I'm going a little bit later, a few minutes over. What's up?
I haven't finished my 2 miles walk yet, and I want to.
You're going right now?
Well, I brought her back, and she was done.
Oh.
How long are you gonna be?
I've got a mystery I have to solve. At least 5 minutes.
5 minutes I can do.
You can do 5 minutes. All right, guys. I'm going to end in 5 minutes here. Let's go figure this out. This has been kind of fun though. So give some thought to this before we go tomorrow. This is some good homework. It's OS exec is totally different. That's what I'm trying to say. So OS exec is the whole point I'm trying to make right here. This last 30-minute tirade has mostly been about we have to create a file lock for the writing, and we're looking for Go functions. And this is kind of a treasure hunt. If somebody wants to help me find it before tomorrow night. Tomorrow night we're going to be doing AMA, by the way, so it's completely different. But if somebody wants to find a way to get a write lock on a file that will be consistent with every operating system, depending on how it does, it'll probably be in OS, by the way. It might be in what is it, Unique or Sync? But one of the ways to do that would be to use this. And to go straight up and use the Unix. These are all the Unix system calls. By the way, if you want to learn the Unix system calls, I'm glad we found this. This is a really great way to read about the Unix system calls themselves, which are displayed anytime you do an strace or you're doing symbolic debugging against a core dump or something. It's really cool. It's really cool. If you want to get really into the security and hacking and performance and stuff of how Unix works, you kind of eventually have to understand system calls. And this particular package is really good at explaining it. It does just say, hey, it's the same one from Unix, right? But it's kind of all there for you to go through. And then you kind of go read about it. Yeah. There's a rendered for drop down up top. Yeah. But see here, there's func flock. See that? That's what I'm looking for. So this is file control flock. So this is how you lock a file descriptor. So you have to open a file, and it would be var run lock probably. And then you would open that file, and then you would get a lock on the file. And then you'd have to actually probably flock. Here we go. This is the one I was looking for. So you could call flock. Now there's an obvious problem here, right? So this is only Unix, and it's going to be fun when we get to do this, maybe Wednesday or whenever, because it's very possible that there is not a cross-platform compatible way to do this, that there's nothing under OS at all that is cross-platform under Go to do this. But if we need to punt and just say, okay, we're only going to do file level locking if we're on Unix because Windows already has it, right? So what we could do is we could make a file called lock underscore AMD64 or Linux or whatever, and then .go, and then that file, we can do that or put a build directive at the top of it. that file will only be compiled into the version of that architecture and that specific chipset for that architecture, the general architecture, the OS and architecture, I should say. And that when you do that, the thing that's really cool about that is that if you have to implement file level locking like this using these OS specific things, you can still do it. It doesn't fuck up your directory of source, because your source is now, Go is aware of the different operating systems. It has multiple ways of compiling binary code and using different lines of code depending on what OS it is. So you can have all of your code be in the same repo and just have those files be tagged for different architecture, or you can do your own naming convention and then tag them internally using a build directive that's just a comment at the top. So this is really amazing. This kind of planning on the part of the Go developers just shows what phenomenal fucking rock stars they were, because they created a mechanism for maintaining extremely complex cross-platform code bases simply and easily in a way that they can be managed together. And we're going to get a picture into this, a stupid little config file thing that we're doing. Because why? Because I actually want to lock the file. I want to make sure that nothing else that's playing this game, that follows this convention is violating it. And I will document it so that in the Go program, so that if somebody else says, hey, you can go get it, you can just use flock if you're writing a bash script. But if you're doing it in Go, you can go, it's already in there, and it's going to call flock for the Unix system. If you're on Unix, if you're on Windows, you're already safe. So I have to leave right now, but the homework, I suppose, between now and in 2 days is to find a cross-platform compatible way to establish a file write lock in Go. I know it can be done in Unix. I know I'm looking right now at the Unix only function that's supported in Go to do it. But what we're looking for, and these things kind of materialize over time, I've noticed. I noticed this about Go. It was like really mature pretty quickly, but lately the things that it's been maturing on have been additions to the cross-platform supported standard library under OS, a standard package in OS. Because why? Because they are things like user config home, right? Those things weren't there before. So we're starting to see those additions get in there now, because all the low-hanging fruit's been kind of covered now, and now we're starting to see this. So I don't know. I'm actually kind of hopeful after our spelunking efforts to find a cross-compatible method to flock a file that we don't have to think about. We can just say os dot lock file, and everything else that uses the thing will use that. And would it be even better is if the Unix implementation of that in Go, compiler flags, shared objects. If the Unix implementation of file locking for that generic way to do it happens to be using var lock, and then we can say, hey, in our documentation, we can say, by the way, Go uses X and Y method to do file level locking using var run or whatever, var run lock. So if you do that in your bash scripts, you're good to go, because you're doing the same thing that Go is doing. That's like the ideal way to do this. And why not? We got time to do it right. So might as well. I am going to go for the night. So I look forward to you guys hanging out and doing something else. I'm going to be doing two things right now. So right now I'm just going to go ahead and shut down the YouTube stream. YouTubers, I see you out there. Thank you so much for coming by. I'm sorry that Twitch is the only way we do chat because of the abuses that have happened in YouTube chat. I had to turn it off. Just so you know, watch the calendar. So watch, twitch.tv/rbxrob/schedule for additions. I'm going to be naming these ad hoc Go compile Go programming sessions will be named similarly, and there'll be playlists out there for that. Tomorrow's AMA, as I said. Friday is Kubernetes, co-learning, and cloud native. And I'm going to go walk for a walk with my wife and come back and play some Dota. So I'm going to go ahead and cancel. I'm gonna stop the stream on YouTube right now. So bye YouTubers, and then I'm gonna